はい、皆さん、おはようございます。どちらでございます。いやー、朝早くから皆さん、お集まりいただきというか、放送に見に来ていただき、ありがとうございます。朝、6時ですよ、まだ皆さん。早いですね、皆さん、早起き。そしてですね、今日は、テスラのインベスターデーでございます。もう、ライブ配信も実は、テスラの方では始まっているんで、今日はですね、これインベスターデーで何が発表されるのかっていうのをですね、皆さんと一緒に、見ながら盛り上がりたいと思います。で、今日は、コメントも出しながら、これじゃないかな。こんな感じでですね、コメントも出しつつ、やりたいと思います。はい、早速皆さん、ありがとうございます。お越しいただきね。はい、おはようございます。ということで、皆さんいつもこんなに早く起きてるんですか？今日のインベスターデーのために早起きした人も多いのかな？はい。ちょっとね、インベスターデー、テスラのライブってほら、これ6時から一応インベスターデーのライブ始まるって書いてありましたけど、大体本ちゃんというかさ、実際に内容が始まるのは、大体いつも20分後ぐらいからだから、ちょっとゆっくり待ちたいなと思いますので、皆さんもね、朝早いし、お茶とか、コーヒーとか持ってきて、ゆっくりと見ましょう。ね、はい。音声、映像変だったら教えてくださいね。これライブ配信でやってますから、トラブっていたら教えてください。で、今、テスラのライブ配信の方ってほら、AI デーの時とかさ、あと、ちょこちょこテスラのライブってありますけれども、ティザー中で流れるこういう画像って結構ヒント出てたりするんですよね。で、これ今まさに流れてるのは、インベスターデーの招待状にも書いてあった画像ですよね。このボディシャーシを横から見た絵が大量に並んでいるっていう、そんなビジュアルなんですけれども、で、ちょっとドット絵っぽくね、テスラのロゴがこんな感じであしらわれてる感じね。これ何が発表されるんですかね。もう見た感じ、これギガテキサスで作られているこのギガプレスを使ったモデル Y っぽいじゃっぽいんですよね。うん。おはようございます。はい、皆さん。目玉報告は何でしょうかね。私の予想は、まず、みんな言ってる通り、次世代プラットフォームの発表、これは、あるじゃないですか。イーロンも言ってたし、発表するよって。で、2つ目はですね、私の勝手な予想なんですけど、これハードウェア4の話出るんじゃないかと思います。そして3つ目、モデル3の新型、リニューアルに関する話で、実は、もうハードウェア4、次、出荷される分から搭載されるわみたいなんで、モデル3の新型ももう間もなく夏出るって言われてるんですけど、もうなんていうかな、それももちろんハードウェア4乗るし、みんな楽しみにしててねみたいな発表があるんじゃないかと勝手に思ってますが、ちなみに私今モデル3の中で話してるんですよ。朝早いしね、ちょっと車でせっかくだから朝のドライブにも行こうと思って、ちょっとね、中にいます。で、セブンに今来てるんで、コーヒー。あんまりね、この時間帯に起きることないんで、いつもだいたい私はもっと遅いんで、すごい眠いです。はい。とにかく大量生産が強化されるんでしょうね。そうね、だから、実際プラットフォームの話もそっか、プラスしてだから発表されることとしたら、この明らかにシャシを使った画像からも分かるように、なんかギガプレスの新しい、バッテリーに関する何か発表かもしれないですね。大量生産できない理由って結局今世のカセロがあんまり大量生産の軌道に乗ってないから、モデル Y の、生産がそんなに早くない。というか、世の数ゼロの生産は全然ボリューム少ないっていう状況。なんかその辺のバッテリーの何かイノベーションがあったのかもしれないですね。はい。テスラ、経済系メディアではメキシコ、インドネシアへの拠点新設の噂が話題。なるほどね。確かにそのバッテリー生産の強化って意味だと、前々から言われてる通りインドネシア にするバッテリー生産拠点というか、ギガファクトリー、車の生産拠点も同時に併設するって言ってたんで、その辺の話ももしかしたら十分ありますよね。新型車の発表楽しみにしてますね。新型の多分新型車っていう風には出ない気がするんですよね。プラットフォームはこんな感じだよっていう風なことな気がするんだけどね。どうなんだろう。サプライズが欲しいですね。テスラの T フォン、パイフォンかというの噂はいつもにか消えましたね。規定してたのに。あれはイーロンがそのうちできたらいいねぐらいのなんかちょっと雑談的な感じで言ってただけだから、そのうち作るんじゃないですか。これ今モデル Y の、ね、そこでバッテリー作りますみたいな話だったらティザー画像にこれ使わない気がするんですよね。何なんですかね、このティザー画像は一体何を示しているのかちょっとわかんないですね。バッテリーだったらもっとバッテリーっぽい使うくないですか。2の話もちらちら聞きますね。そう、イーロはモデル2って名前にはしないって言ってたんですけど、おそらくその小型車の話ですよね。で、次世代プラットフォームは、いわゆる小型車に関する発表というか、で使われるプラットフォームですから、それの発表はあるとは言ってましたけどね。てか、相変わらずこのテスラのライブって、ね、始まんないですよね。だいたいいつも20分ぐらいしてから、やーって言うんでイーロンが出てきてっていうパターンなんですけど、まだあと10分ぐらいは始まんないかもしれないですね。10分どころか前回の AI で2の時とかなんかは2、30分ぐらい、なんかずっとこういう映像が流れてましたよね。いつになったら始まるんじゃいっていう。そう、モデル A。モデル A なのかわかんないですけどね、まだ。なんとも言われてないんで。わかんないんですけど、何になるんだろう。名前はね。モデル T とかね。いやー。で、まださ、あれですよ。外暗いですよね。2月、3月か。昨日で3月になったばっかだけど、まだこの時間ってこんな暗いんですね。もう暇すぎて、世間話し始めるっていうね。はい。早く始まってほしいですけど、そうね、あとテスラ、なんだろうね、発表あるとしたら、他にはあんまり考えられないですよね。いわゆる、インドに、新設工場の話なのか、バッテリー生産の革新の話なのか、次世代プラットフォームの話なのか、新型車両の話なのか、その辺かな。あとハードウェア4の話、現実的なのはその辺かな。多分、だからロボットがどうとか、そういう話は今日しないと思うんですよね。テスラボットとかね。わかんない。サプライズがあるかもしれないけど。パナソニックに資本があれば世の中せる早まるのになと。まだまだ電池足りない。いや、パナソニックも今、ほら、アメリカの工場を作ろうとしてますよね。セル工場を追加で。結構な投資してるみたいですよ。何千億円かね。でも、結局今から作っても完成するのって、数ヶ月後じゃないですか、早くても。1年後、2年後とか。だから、パナソニックの世の中セル生産もですね、そんなすぐには始められないっていうことなんだと思うんですけどね。なんだっけ、ネバダ州の上のところにできたっていう風に言われているさ、パナソニックの名前なんだっけ、バッテリー施設の。ちょっと調べてみようか。そうそう、今日さ、ニュースやらないんで、その代わりに、このインベスターデ っていう風に、インベスターデーのライブ放送で開催させてもらいますっていう風に言ったんですけど、何個かね、気になるニュースがあったんです。それね、取り上げようかな、後で。パナソニック。パナソニック。やべ。バッテリー工場。これか。そうですね、日経が報じてる通り、この左の4のカプセルセルを建てるために、米カンザス州に、2024年をめどに生産開始だから、もう今、多分建設してるんだろうけど、まあ、完成するのは来年ですよと。6000億円投資するんだって。すごいよね。はい。そんな感じらしいですよ。おはようございます。AW139MAX さんね、朝からありがとうございます。ちなみに始まるまで私気になってた、投稿、ちょっとね、見たいんですけれども、先週じゃないか、前回月曜日にですね、テスラのマジックドッグがアメリカで発見されましたっていう報道っていうかご紹介したじゃないですか。なんとですね、アメリカ公式でもうローンチしました。このテスラ社以外の EV でも充電できるこのマジックドッグ、これがね始まったんですよ。ついに来たかって感じなんですけど、このねテスラのチャージングチームの公式ツイッターに動画が投稿されてですね、その様子がねつまびらかになったんですよ。ちょっと見てみましょうか。はい、テスラアプリから、テスラじゃない人の充電っていうところをタップするとですね、充電できる、はい、これ場所が表示されますと。で、そこに着いたらですね、それをタップして、チャージヒアを押すと、クレジットカードとか、ストールの番号とかが出るんで、OK って言って、これピッてやると、アンロックされるらしいの。すごくない？ほら。こうやって出るんだって。CCS1 のドックがガチャンって装備されたスーパーチャージャーで、充電中はこうやってね、リアルタイムに今いくらですかとか、出力とか全部アプリで見れるようになってるのってめっちゃ良くない？スマートですよね。で、最終的にどれぐらいの充電だったかっていうのが見れると。めっちゃいいじゃんというね。で、マジックドッグ、こんな感じなんだって。いや、すごいね。ほら、このロックされてるんですね。やっぱほら、この銀色のアルミっぽい掘り出し金具がありますよね。だから、通常時は、テスラオーナーが普通にすぐ充電したいときは、ここが取れないようにガチャンって多分ロックされてるんでしょうね。で、実際に、このノンテスラの人たちが充電するときは、このロックをですね、スーパーチャージャー側の、なんていうの？機構がガチャンって解除する。で、それ抜ける。これごと抜けるってことですよね。で、多分、これごと抜いたときは、この先端のテスラ専用の口と、このアダプターの間は取れなくなるって感じなんでしょうね。持ってかれちゃうからさ、いたずらとかで。はい。ということみたい。すごいよね。だからさ、これって前回も言った通り、茶デモでもいけるんじゃねみたいな話ありますよね。だから、茶デモのさ、なんていうかな、アダプターにこれ変えればいいわけじゃないですか。日本、これがもしね、スーパーチャージャーがもっと増えてきて、テスラオーナーが不便なく使えるぐらい空いてるような状況になったら、このね、チャデモバージョンを導入してほしいですよね。導入してほしいっていうか、多分導入すれば日本の EV のおそらくですね、インフラ、だいぶ変化があるんかなっていうふうに思います。他社 EV も充電するようになる。スーパーチャージャー。ただですね、1個懸念点として、これ、スーパーチャージャーの、コードの長さっていうのかな、ストールの長さって変わらないんですよ、コードが。だから、何が言いたいかというと、 結局他社 EV にあんまり充電させる気ないよねみたいなところはあるんですよね。いや、なんでかっていうと、EV によっては左前とか右前にあったりするわけじゃないですか、充電口が。なのにそこまで届かないんですよ、ケーブルが。ってなると、まあなんて形だけっていうか、なんていうかな、その他社 EV も充電できるけど、まあ充電しにくいよねみたいな状況をあえて作ってるんかなみたいな。でそれによってまあ補助、アメリカからのそのインフラ整備のお金はもらえつつも、テスラの充電棒を増やして他の他社 EV の人たちをあんまり充電させなくする作戦なんじゃないかなって私勝手に思ってるんですよね。少なからず充電しにくいんであんまり行こうとは思わないと思うんですよね、スーパーチャージャーでわざわざ充電しようとは。エレクトロファーアメリカとかさ、そっちの方が 350kW の充電器とかあるんで、別にスーパーチャージャーでわざわざ充電する理由もそこまで、強くないですよね。緊急時用に充電できるよみたいな話。だからテスラうまいなと思いましたね。で、充電ちょっとできないやぐらいだったらまだいいんですけど、駐車の仕方がさ、また問題になってくる可能性ありますよね。いやっていうのは、これスーパーチャージャーって、普通はテスラ車だったら後ろからバックして入れるわけじゃないですか。後ろからバックしてテスラ車左後ろに全ての車に充電器をつなぐ場所があるんで、ガチャンってそのままつなげばいいというか、スムーズにつなげる位置にスーパーチャージャーのストールも設置されてるんですけど、他社 EV だと例えば右後ろとかにあったらさ、右隣のスーパーチャージャーのストールを使うことになるんですよね。そうするともうそのすぐ右側の駐車区画にはテスラ車止められないわけですよ。だってストール使われちゃってるから。とか、左前とか右前にある車だと、多分前から突っ込んでもコード届かないんで、なんていうかな、駐車枠をまたがって横に止めるやつみたいな、もう出てくると思うんですよ。だから駐車枠2個分使っちゃうみたいなね、そのマナー違反の車が出てくる可能性もありますよね、これね。だからどうなんだろうみたいな話はありますけれども。日本でも多分ね、これ出てきたらそういう人出てくる。結構マナー悪い人出てきて問題になる気がするんですよね。特にテスラとか、ほらみんなツイッターとか活発にやってるからさ、で写真撮られてなんか晒されるみたいな。怖いですよね。そういうマナー違反もね、少しずつ多分最初は出てくると思うんですけど、そういうのをリテラシーがみんなちょっとずつ上がってきて、みたいなことになるんでしょうけどね。皆さんね、映像大丈夫ですかね？映像、音声。調子悪いかな？音出てない？ちょっとね、回線がですね、そんなに強くないんで、この辺。モバイルでやってますから、ちょっとね、すいませんね。もしかしたら、プツプツかもしんない。延長ケーブル、確かにね。いや、でも延長ケーブルは売らないんじゃないかな。結構だってケーブルって言っても高いですから。スーパーチャージャーって、あと高電圧だからあんまりなんか汎用性があるものだとちょっと危ないし。ね。はい。ということで、インベスターで相変わらずまだ始まんないですね。いつも通りイーロンタイム発動しますね。もう20分ね、経ってますけどね。4時、6時になってから。外もね、ちょっと明るくなってきました。はい。めっちゃ早いですねってね。そうなんですよ。今日早起きでございます。他の EV も左後ろにすればいいのに。ね、確かに。統一してほしいですよね。なんか全部ね。わかりにくいよね。さあ、ということでですね。それぐらいかな。私が今回見てて気になったと思ったのは。あとは、これとかもちょっとね、気になったんですよね。 この NHTSA が FSD、フルセルフドライビングベータっていう名前で、この自動運転プログラム、運転支援プログラムを売り出すなっていう風なことを言ったんですよね。それでカリフォルニアの方ではですね、それに沿って法律というか、禁止する条例もできちゃったりして、その名前で売り出すことを、実際にテスラもですね、FSD ベータって名前で、売らなくなっています。実際にカリフォルニアの方ではね、アメリカ全土かな。はい。これに対していろんな人が反応してるってことかな。このチャンク・クックさんってね、FSD ベータテスターですよね。結構昔からいる。でこの人は、アップデートで、この FSD ベータのオペレーションがだいぶ変わるよみたいなことですね。だからNHTSA がリコールを出した関係で、それに応じたアップデート、つまりその交差点での挙動とか、あとは速度を守るっていうのはね、結構簡単な話だと思うんです。多分ね、その交差点での FSD ベータの挙動がだいぶ変わると思うんですよね。で、みんながっかりしてるみたいな。はい。はい。そうね、だからこれによるとですね、まだそのプッシュは始まってないみたいですね。そのなんていうの、リコールに対する修正アップデートっていうのは来てないんだけれども、テスラが発表したこのプレスリリースによると、そこら辺を制限するようなインプルーブがあるかもしれなくて、詳細はまだ分かんないんだけど、その特定の状況下でブレーキとかアクセラレーションがちょっとの挙動が変わっちゃうんじゃないみたいなのをみんな心配していると。つまり今の FS リベーターも結構もう優秀なわけですよ。間違えることもあるけど。逆になんかそこら辺が制限されて、その状況で FS リベーターオフになったらすごい嫌だよねみたいなことですよね。はい。どうなんだろうね。どの辺までこの FSD の挙動を制限してくるのかっていうのは結構注目ですよね。
そうですか。
なんかシリが反応した。いや、なんかこの人とかね、イーロン・マスクにFS ベーターの金返せって言ったりね、してますけれども。そうね。てか、これあれなのか、FS ベーターの、そうですね。なるほど。リコールするっていう表現がちょっとね、多分 FS ベーターを取り上げるってことじゃないと思うんですけど、だからね、ここら辺ですよね。インプルーブされるんですけど、特定のね、環境での挙動がね。いやー、ちょっとわかんないですね。はい。これは気になったところです。アメリカの方でも結構、この自動運転に関する風当たりが強くなってきたと。でもそれだけ進化しているってことの裏返しでもあるとは思うんですが、ただ、やっぱね、テスラの自動運転の、 開発の仕方ってやっぱり市場に出してなんぼなんですよね。もちろんそれで事故がね頻発してたりしたらダメなんですけど、ギリギリのところをすごい攻めてるんですよね、テスラって。人が死なないように事故に遭わないけれど失敗例は欲しいみたいな。で失敗例と成功例が大事なんですよ、データとしてね。成功例っていうのは、人間が修正したバージョンと FS3 ベータが失敗したバージョンのそのデータがそれぞれ欲しくて、人間がねこの交差点で微妙な挙動をしたらこういうふうにグッてハンドルを回すわけですけど、そのデータをセットで欲しくて、確かにそういう状況って事故起きやすいんだけれども FS3 ベータの成長には欠かせないデータ。皆さん始まりましたよ。来ました、インベスターデー。さあちょっとね、またこの話は後でやりましょうか。
Good afternoon, everyone.
はい、あっちは夕方、お昼なのかな。
My name is Zach Kirkhorn. I lead finance here at Tesla, and welcome to our Investor Day.
はい、最初はなんかファイナンス系の話なんですかね。財務担当の人だそうです、テスラ。
For those of you here in the audience at our global headquarters in Austin, Texas, we welcome you. Thank you for being here and thank you for traveling in. For those joining us virtually, thank you for being a part of the day today. So as we reflect back on the history of the company, there's been distinct phases of product advancement, technology innovation, and rapid volume growth. The most recent of which has been the global expansion and localization of the Model Y program. And so today, we want to talk about the future. We don't want to talk about this quarter or next quarter. We want to go further out into the future. And we've divided today's presentation into 3 parts. The first of which, we're going to go macro. What does it take to convert Earth to sustainable energy generation and use? The second, we want to talk about Tesla's contribution to that global need. And we're going to go function by function through the company, and you'll meet our entire leadership team, and we're going to get into the details of what those teams are doing as part of the broader goal. And then in the third part, we're going to bring it back up and talk about what this all means for the company as a whole. So
なんか
before
1
we
個目
get
は
started,
その
statements made
なんか
in this
3つぐらい話すっ
presentation
て言っ
are
てて、
forward-looking
なんか
statements
1個目はなんだ
that
っ
are
け、そ
subject
の
to risks and
何
uncertainties.
地球のこれからみたいな、地球に対するその
So with that, let's get started.
にどうしていくかみ
Part
たいな。
1, Elon
2
Musk
つ目はなん
and Drew
か
Baglino.
環境問題に関してで、2つはテスラがカーボンニュートラルにコミットするためにやること、そして3つ目がその会社全体のことみたいな、そのマクロからミクロに話すよって言ってます。
Master Plan Part 3.
イーロンが出てきました。
So, as Zach was mentioning, the thing that I think is we wanted to convey, probably more importantly than anything else that we talk about here, is that there is a clear path to a sustainable energy Earth. It's not, it doesn't require destroying natural habitats. It doesn't require us to be austere and stop using electricity and sort of be in the cold or anything. The story, and I think that this holds together quite well, and we'll be actually publishing a detailed white paper with all of our assumptions and calculations, is that there is a clear path to a fully sustainable Earth with abundance. In fact, you could support a civilization much bigger than Earth, than much more than the 8 billion humans could actually be supported sustainably on Earth. And I'm just often shocked and surprised by how few people realize this. Most of the smart people I know actually don't see this clear path. They think that there's not a path to a sustainable energy future, or at least there's not one that is sustainable at our current population, or that we'd have to resort to extreme measures. None of this is true. So we're going to walk through the calculations for how to create a sustainable energy civilization.
うん。なんか地球これからちゃんと考え、なんかまあ簡単に言うともっと地球はもうどうなってるかちょっと考えて行動してないとダメだねみたいな話ですね。人類のこれからのことを考えた活動をしていかないといけないみたいな。
It's like if for some of this I'm going to elaborate because there's a very wide range of technical expertise out there from people who are like, you know, whatever level 9 wizards in the subject to people who do not do engineering at all. So, if you have a gasoline car, you're converting less than a third, often maybe only 25% of the energy in the gasoline is converted into motion. The rest is turned into waste heat. That doesn't do any good at all. And there's a lot of energy required even to get the oil out of the ground, to refine the oil, and to transport the gasoline to the gas station. So when you look at all that, for a typical gasoline car is actually going to be using less than 20% fully considered of the energy from the oil actually goes into motion. So this is when we see people doing calculations for what does it take to create a sustainable energy Earth, they assume that the same energy amount is required for an electrified civilization versus
結局これ前から言われた話ですけれども、その地球で使われているエネルギーって 80% が石油ですよね。で、車内燃機関ってガソリンスタンドにガソリンを運んで実際に走らせるまでの熱エネルギー変換効率 20% 以下だよね。本当に CO2 を減らしていくっていう話だったらこれ効率性最悪だよねみたいな。だったら火力発電所で効率よく発電して電線を使って運んだ電気で EV 走らせた方がそのガソリンを直接燃やすより全然効率いいよねみたいな話ですね。まああとここからはあれですね、ソーラーパネルの話ね。
We're trying to have assumptions that are reasonable, not overly optimistic, in fact slightly pessimistic. So it's really better than half, but just say it's easy to make the argument that we need half as much energy with an electric economy versus a combustion economy.
Yep. So how the master plan works? You want to talk
about? So the thing that is needed at very large scale that is not currently present is a vast amount of battery energy storage. Our rough calculations are that this is about 240 terawatt hours or 240,000 gigawatt hours. This is a lot of batteries, but it is actually a very achievable amount. We'll go into details on that. So that's a combination of electric vehicles and stationary storage. So if you've got solar or wind, you've got to store the energy when the wind is not blowing, the sun is not shining. And so we're assuming sort of an 8-to-1 ratio of stored energy to power. So 30 terawatt hours of power, 30 terawatts of power. Our actual capital expenditure calculation for manufacturing investment is more like 6 trillion, but we made it higher to make it 10 trillion.
And this is across mining, refining, battery factories, recycling, vehicle factories, all the things that we're going to talk about needing to invest in to build the sustainable energy economy.
Yeah. Now, if you look at the total world economy, it's just under 100 trillion. So if this was spread out, say over 10 years, it would be 1% of the global economy. Over 20 years, it would be 0.5% of the global economy. So this is, not a big number relative to the global economy. As Drew mentioned, you need about half as much energy with an electric economy versus a combustion economy.
エネルギーが今石油由来からサステナブルエナジーに変わっていく
of the land area of Earth.
で、そうなった時って、エネルギーが
Like,
もうほとんど
generally
こ
people
こ
don't
由
realize
来にな
quite
る
how much
未来がある
energy
とし
is
たら、
retained from the
それっ
sun.
てもう
It's
2022年の
roughly a gigawatt per
世
square
界の
kilometer.
GDP のこれ 10% 占めてもうおかしくないみたいな。
The sun doesn't shine all the time, but it's
市場予
if
想
you
ですね。
multiply that by
うん。
say
で、テスラはそれを推進していくよと
4 to get the
いう
continuous
ことですね。
power, 4 or 5, then that gives you the land area of solar. And you can put wind and solar often in the same place. So a lot of places that currently have wind, you could have solar there and you double your energy.
You can also put wind offshore. It doesn't even need to
Yeah.
be on land, so wind is even more flexible.
You could put solar offshore too.
Yep.
So Earth is 70% water. Anyway, the point is that with a pretty, really a remarkably small amount of Earth's land area,
これ最
where
初
you
は
go
やっ
fully
ぱこれ
sustainable.
そうですね。
Yeah.
And from a
ソーラーパネル
resources
系
and
の
raw
話から
materials
始まっ
just
て
to
ます
support
よ
this
ね。
transition. We'll go through that in detail, but we do not see any
正直言って
insurmountable
まだこの
resource
辺はね、
challenges at all.
僕ら
In
そんな
fact,
に興味ないとこ
in
ろ
the
です
end,
よ
we
ね。
should be
皆さんどれぐらい興味あるか分かんないですけ
adding
ど、
less
テスラの
ore to accomplish this economy
この
than we
車
do
以外の
the
方、
fossil fuel economy, and we're going to talk about
ソーラーとかストレージとか
Just
さ、
to emphasize that again,
その辺ですよね、
the
まずね。
electrified economy will require
これを一番最初に持ってきた
than the
っていうの
current
は
economy does.
どういうあれなんですかね。
Less.
まあ一番見てもらいたいところ
So this is the
っ
plan,
てことで
and
すよ
now
ね。
we'll get
結
into
局ね、
a
そ
little
の
more of the
テ
details
ス
of
ラ
the
の
plan.
方向性
Basically, five
として
areas
一
of
番最初
work.
にこの
First, renewable
サステナブル
power,
の
the
世界をど
existing
う
grid.
やって作っていくかみたいな
Second,
話
switch
を
to
最初にするって言
electric
ってたんで、
vehicles. Third,
結構もう
switch
大
homes,
きな
businesses, and industry heating
企業
to
ミッション的なところから
heat pumps.
話が始まってますよね。
Fourth, high temp heat delivery and storage
環境問
for
題ね。
high temp industrial and chemical processes, and a little bit of green hydrogen in there for chemical processes that need hydrogen. And finally, sustainably fueled planes and boats. These are the five areas, and we're going to go into detail on all of them.
Yeah, I mean, my personal opinion is that as we improve the energy density of batteries, you'll see all transportation go fully electric, with the exception of rockets. That's awkward. But you can make the fuel with CO2 and water. So you can make methane with CO2 and water. So
And you can do that with just electricity. So.
yes, exactly. So in fact, on Mars, if we hopefully get there at some point, the atmosphere is CO2 and there's water ice throughout Mars. So you can take the CO2 and H2O and turn that into CH4, which is methane, and oxygen. So ultimately, even rockets can be electrified.
So first, repowering the existing grid with renewables, and this is going to be a consistent theme. You'll see our estimates for the number of terawatt hours, terawatts, and trillions of investment at the bottom of the page. You know, this is already actively occurring in front of us. 60% of the generation added to the US grid was solar in 2022. And actually,
CO2 減
on
ら
a
していくか
year-on-year
みたいな
basis, solar
話で、
deployment is
1個
growing
目は
50%
テスラはこ
year-on-year
のストレージ
as
と
of 2022.
ソーラーパワ
This is a
ーによっ
serious
てこのグリッドをもっと
upswing.
リ
And if
ニ
we
ューアル
continue
パワー
this
に変え
trend,
ていくっ
this is going to
て
be
いうの
behind us
で
before we even
この
know
目標ですよね。将
Second,
来的
switching
に
to electric vehicles. Again,
GDP の 10% ぐらいになるような規模の市場を作り上げていく。
Obviously, Tesla is heavily engaged in this
という意味
activity
で
as
今
along with many
35% は
others.
それをやると。で、
Overall,
2つ目
EV
が今
production
我々
grew
が乗っているテスラ車
year-on-year
EV
in
を売って
2022.
いくことに
And
よっ
EVs hit
て
an amazing
その
10% market share. I mean, it's an awesome
目
milestone.
標の
I'm super
21%
excited
分
to
を
see that. I gotta.
Yeah, I mean, this is obviously happening very rapidly, and I mean, I think really all cars will go to fully electric.
環境問題、はい、目指しているものがある企業には魅力を感じますね。そうですね。なんかこうやって定期的にやっぱ僕たちが目指しているのはここなんですっていうふうに社長自らこう話してくれる方が、まあ応援
And we actually took a somewhat conservative
まあ
assumption here
ね
in
応援
terms of
でき
how
ま
many
すよね。こっ
batteries
ち
are
の方が安
required.
心感もあるし、
The more the fleet is
何を
autonomous,
している企業なんかも分かりやすいしね。
the smaller the fleet needs to be.
消費
just
者
from
と
a
して
utility
も
basis. So we're not
株主
accounting
とし
for
て
all
も
of those benefits.
まあ
We're really
傍観
not
者
showing
と
those
して
benefits at
も
all in this number.
まあやっぱりこうあった方がねこういう発表っていいですよ
And
ね。
what does this fleet look like? You know, just rough view from our perspective. Of course, we could be wrong, but
口だけじゃな
you
く
know,
現実
you
に
can
す
see
るとこ
the
ろ
sort
本
of
当にそう
breakdown
です
of
ね
the。fleet by millions of vehicles.
さあ皆さんこれこの絵右側のねこのカバーがかかってるところですよ。皆さんここですよ。左側はねモデル SX3Y あとセミサイバートラックありますけれども 右側のね。
Some debate as
これ
to
バンでしょ
whether
絶対。
it's a number less
右側のちょっと背の高いやつ。
than needed today. There's
何今
roughly
の
2 billion cars and trucks
何今の
in
絶対
operation
バンでしょ
globally.
今の。サイズ的に。
Yeah, so what we show here is actually
一番右のはロードスターっぽかったけどね。
or so.
背が低いから。
So
Yeah.
we're represent 1.4 billion
なんだ今の
or so, so a smaller
これ
fleet.
今から発表さ
And,
れこれ
you know, the numbers
300
here in this presentation
ミ
are
リオン
around
って書いてある
85
これ
million vehicles a year produced.
何これ
Just to give you a sense of how we're thinking about this. Again, we're
700
gonna
ミリ
put
オ
all
ン
these assumptions
え
up online and, you know, encourage
グローバル
people's
フリー
thoughts.
ト700ミリオンがこれあれか大衆車か
So,
ちっちゃいやつか
yeah,
300
so
ミリオンこれ
we're
バンじゃん
basically
絶対
towards an electric
300
autonomous future.
300ミリオン
Yeah.
え
And one of the reasons why EVs are so enabling is this end-use efficiency point.
嘘
Um,
マジで
Tesla
マ
Model
ジでバン
3
作るの
is
か
4 times more efficient from the well to wheel than a Toyota Corolla. And that's all about the
え
efficiency
な
of
んか
getting
どうします
the
みんな
electricity to the
アルファードみたい
car
な
in a
テスラの
sustainable,
EV 出たら
energy economy.
日本人めっちゃ買うんじゃない
In
勝手に盛り上がってますけど
transferring
私
energy to motion on the road.
はい
When
この後
compared
発表
to
がある
the
かもしれないん
engine
で
in
ちょ
the
っと
Toyota
ちょっと落ち着いて
Corolla
待ちま
and
すか
all the, you know,
はい
extraction, refining, transmission distribution of the gasoline to the Toyota Corolla. And just for this is a fun reference. Model 3 can drive
はいメイムさん
over a
ね
mile
スパッチャありがとうござい
on the
ま
energy it takes
す
to boil a pot of water for pasta. And then it can drive another mile on the energy it took to cook the pasta. And that pasta is 1
商業
pound.
車ねそうね EU とかアメリカだとバンって
Just to give you a sense of just
商
like,
業車なんですけど
like,
宅急便運ぶやつ
it really
と
doesn't use a
か
lot
た
of
だそれをちょっと
energy
改造
to
すれ
move
ば
that 4,000
ミニバンみたいにもなるんで
down the road.
日本でね
Also,
に大人気
heat
の
is a
ミ
lot
ニ
more
バ
energy
ン
than motion.
Yeah.
のテスラが走
Yeah.
る日もあるかもしれ
But
ない
people, you know, you spoil a pot of pasta, you don't even think about it. You know, it's just interesting how efficient these cars are. Next, switching to heat pumps in homes, businesses, and industry.
で3つ目ですね
You know, right now, heat pumps meet
1
10%
個
of
目
building
が
heating needs.
リニューアブルエナジーにグリッドを変えて2つ目が車を売ることで3つ目
Heat pumps can serve,
これ
you
が
know, heat
世
applications up to
界
200C in
の
businesses
工業
and industry. And from an
ヒートポン
investment
プ
perspective, as you can see on this page, it's actually the
を
lowest hanging fruit in
テスラ
terms of
作っていくってこ
displacing
と
fossil
ですか
fuels.
ね
You might be saying, well, what exactly is a heat pump?
もっと効率
So,
のいい熱交換システムを作るっていう話
heat pumps don't move heat, don't create
前から言われて
heat,
る
they
よ
move
ね
heat.
車に使われてるオクタバル
When you
ブ
think about like the
を
natural gas
なんか家とかに
furnace in
転
your
用できれ
house,
ば
like, it is
熱の
generating heat
うまい
itself,
使い
but
方
what
で
the
き
heat
るよう
pump
に
is
みたいな
doing is actually moving heat from outside of your house into your house. They're just an air conditioner or a refrigerator in reverse. So we're surrounded by heat pumps. There's like, you know, they're all over this factory. They're in your house, and all this really is about bringing them to displace all the fossil fuel heating and all the homes.
これ
and businesses
左
in the
多分エア
industry
コンですよね
that
コ
we
ンプレ
can.
ッサー
And
ヒー
from
ト
an
ポン
end-use
プ
efficiency perspective, is a three times reduction in the total energy required
あ
to
の
heat these buildings.
ガスストーブより
So
3
a
倍
real obvious thing to do.
効率いいらしいね
Yeah,
ヒートポンプの方がまあ確かにね
Cars,
その
yeah, no,
あでも
it's
どうなん
default,
だろう
and at some point,
エアコンとかだとま
we might make a heat
う
pump for a
ん
home.
本当かな
Yeah,
そうなん
maybe,
だ
maybe.
本当かなとか言って
Next, a little bit more detail on electrifying high temp sort of industrial chemical processes. So over 50% of industrial heat is greater than 400C. Where, you know, cement, steel, fertilizers, chemicals, plastics, metals refining all need like 1500C. So we need a solution here. Ultimately, it's purpose-built equipment that enables electrification. You know, carbon graphite is stable up to 2800C. There's other options in the 1500C range, like silicon carbide, other materials. So the idea here is you create and store heat when renewable power is available. If this is a sustainable energy economy, you know, renewable energy is intermittent. Peak of the day, you've got more generation than you need. You make a bunch of heat then, and then you transfer that heat into the industrial process 24 hours a day using the stored heat you created when the sun or the wind was blowing. That's the
あー
concept
なるほど
here.
ねまあ
And then
これ
on
っ
the
てちょっとイン
hydrogen
チキな
side,
気がするそ
we
のなん
also
か
need green hydrogen to decarbonize metals and chemical refining processes. This is things like ammonia, making steel. You know, there's roughly 120 million tons of hydrogen sourced from fossil fuels today to do these things. And hydrogen can also directly replace coal, which is currently used in a ton of steel production, through a process
なんか
called
工業
directly
用の
reducing
ほら
iron
熱が必要なさ
blast
鉄溶かしたりとか
furnaces
さ
with, a
なんか
hydrogen
化学
reducing,
的になんか反応
direct
させて
reduced
みたい
iron
な
furnace.
超高温で
And this is the way to
なんか
eliminate
やんなきゃい
fossil
けない
fuels from these
溶
aspects
解炉
of
み
the
たい
economy.
なのところで使うエネルギーの
Yeah,
話
so
だと
I
思うん
mean,
ですけど まあそもそも電気でやりましょうよと、電気炉みたいな。でそれは風力発電とか、それから太陽光発電で作った電気を使えばそれいいよねみたいなのとか、あと水素ですね。やっぱこうテスラも水素ちょっと考えてるんだなっていうのは思った。まあ工業用で水素をまあ貯めておけばいいよねみたいな。その例えば電気だけじゃなくて、そういう風な
I mean, some of that's been done for decades and decades. This is not
CO2 を出さない
technology.
H2 でこう燃やせばいいんじゃないみたいな。
And
やればいいんじゃないみ
lastly,
たいな、高温で。
a small part of the pie, but a necessary part of the
適材
pie
適所でやりま
is
しょう定期的
sustainably
なね。
fueling planes and boats. Shipping accounts for 3% of global CO2. It's ripe for electrification. Even with lithium iron phosphate, long-haul ships can be fully battery powered. So that's a great opportunity to
あースーパーステッカーありがとうございます。あちょぴんちゃんさん。
With some improvements, we'll get long haul underway. But even in the meantime, we can leverage sustainable aviation fuels produced and stored using excess renewable electricity. There's a lot of work going on in this space, and it's
Yeah, I mean, to really get long-range aircraft and long-range shipping to use lithium-ion, you need to redesign the ship and not just
or the plane.
And the plane to take advantage of the fact that it is a new source of energy. It's a different architecture. So, just like with an electric car, you wouldn't just
入れ墨かと思ったらあれ全部
gasoline car and stick a battery in it.
腕毛かって。
Very suboptimal.
Q さんちょっと面白いですね。
It's much
そうですね。ア
more
メリカ人はね、
efficient
毛が
to
濃いん
have
です
the
よね。
battery be the structure of the car.
笑っちゃいました。
And
これあれですね、一番最後のこの海運系ですよね。だから荷物、流通、結構船がすごい結局エンジン、ディーゼルエンジンでガンガン回して運んでるじゃないですか。それを電気化したらいいよねみたいな。つまりもう本当、世界中のありとあらゆる内燃機関を電気化すればだいぶ変わるよねっていうことですね。もしアメリカでもそのトラックが今1000ミリ始まりましたけど、アメリカって全土で出してる排気量 CO2 のうちの10何%がトラックなので、だからそれが電気自動車に変わるだけでもだいぶ変わるし、飛行機だとか船、これが EV っていうかエレクトリファイされればだいぶ減るよねって話なんでしょうね。アナックさんのね、スパチャありがとうございます。
This gap is going to be closed really quickly. When we look at electric vehicles, they have to grow 11x. Well, they grew 60% year on year last year. That growth rate is also going to close pretty darn. That gap is going to close pretty quickly as well. And lastly, storage. Tesla's energy storage business has grown at 65% CAGR since 2016. The global, energy storage business is accelerating pace as well. I mean, all these gaps are going to close, especially as this momentum of the transition to sustainable energy.
テスラ株が下がってきた。
And of course, our goal on this page is 20 million EVs
ちょっ
per
と待
year.
ったからね、最初あんまりつまんない話しちゃってるから最初。なんかこれ微妙なんじゃねみたいな。結構期待してたからみんな。新しいプラットフォームが発表されるってね。なんかそのテスラエナジーとか CO2 どのこうみたいな話みんな興味ないですよねきっと。大した発表じゃねえと思われて売られてるかもしれないですね。
Like what we invested last year in the fossil fuel infrastructure.
まあせっかくだから。
And it's 60% of that investment. So actually, building this sustainable energy economy is less than extending the fossil fuel economy from a year-over-year investment basis. So very doable. When we look towards, does this fit on the planet? Absolutely.
サステナブルエナジーに関する投資が化石燃料に関する投資より少ないのはちょっとどうなのみたいなね。ちなみにちょっと一瞬
This is an order of magnitude, more than an order of magnitude difference between farming and what we're talking about for sustainable energy land.
And it doesn't need to displace farmland or forests or jungle or any kind of ecological preserve. It can be used in very sparsely populated desert regions.
なんかすごいインベスターデー始まってからちょっと荒れてますね。
I mean, 0.2% can fit into a lot of places.
Yeah, there's essentially no meaningful ecological impact. In fact, transition to a sustainable energy economy would result in a substantial reduction in current ecological impact.
今来ました。はい、こんばんはっていうか、おはようございます。
And
よ
what
うこそ。
about on the mineral extraction side? So this is a cartoon that sort of gives you a sense for all the ore and the like extracted minerals that are coming out of the earth every year. It's about 68 gigatons. So each truck is a gigaton. What does this look like when we're in a sustainable energy economy? Looks like that. Fossil fuel extraction disappears. We replace it with the materials required to fulfill the sustainable energy economy. It actually reduces. Now, it's not to say that we don't need to continue to explore, bring on mining and refining for the sort of specific materials for the sustainable energy economy. We do. But the investment and mass flows are all very achievable just looking at what is already happening on the planet. Like, this is nothing out of scale of what has been done and is already being done. And then when we calculate it on a sort of, element by element basis, the resources are there to support the transition. This is cumulative demand to move in the sustainable energy economy direction until 2050 relative to USGS resources today. We're not breaking the resource bank for any of these materials. And then when we look at what really happens as we move forward, history teaches the more we look, the more we find. What people think happens is, oh, there's this many resources, next year there's going to be less because we're going to extract them. What actually happens is, as we extract resources, we find more. And you can see on the right what has actually occurred with the key materials to the sustainable energy economy. Since 2000, as the sustainable energy economy has been growing and Tesla's been growing and all the industries around us have been growing, the actual resource availability has increased, not decreased.
価格ですよね。
Yeah,
各素材の。
quite a bit of confusion about lithium.
で、さっきの
Lithium is
そ
extremely
の
common. It's one
採
of the most
掘
common elements
するのにどれぐらいの
There's no country that has the monopoly on
トラック、
or
まあその
close to it.
採掘するのにもその CO2 出すよねみたいな話あるんですけど、そのテスラは2000、まあ、もうちょっとするまでには実際にそのうちの数パーセント、さっきだと5台ぐらいかな、3、4台ぐらいのトラックはもうサステナブルなエネルギーでマイニングしていくってこと、マイニングというか運ぶってことですかね、
And
素
the
材
same
を。
is true for these other materials. And this is, again, these are not like crazy technologies. It's just the investments need to be made, and the investments, they're not gigantic. They just need to happen.
Right. Nickel is maybe of them all the trickiest one to solve. But as we showed with the graph there, maybe need like 30% of the world's known nickel reserves. So
And the nickel reserves have actually grown since
yes,
2000. So.
there is more. Yeah, exactly. So, and you only need nickel for basically aircraft, long-range boats, and very long-range cars or trucks. But the vast majority of the heavy lifting for electrification will be iron-based cells. And iron is actually literally the most common element on Earth. So, little trivia point: if you say like, what is Earth made of? By mass, it is made of iron more than anything else, and second, oxygen, and then everything else after that. So, basically, we're a muddy rust ball, is what Earth is. So, an iron cathode is sort of, you're definitely not going to run out of iron. There's so much iron, it's insane. So that's it, yeah. So.
Yeah, and ultimately, this resource extraction, we go through this effort, we build these batteries, and then we recycle these batteries. So ultimately, we're doing this to build this sustainable energy economy, but the maintenance amount of ore that we require is really an order of magnitude or more, less, because of recycling. So in the end, a sustainable energy economy is within our reach, and we should accelerate it.
なるほど。まあでも前から言われてる話ですよね。なんかそのマイニングした素材を、まあ、最近はちょっとバッテリーで素材リサイクルし始めてるよとか、あと今イーロン言ってたのはそのてかニッケルいるんだっけみたいなね。ニッケルそのリチウムニッケルってその 高密度のバッテリーにやっぱり使ってるんですよね。ロングレンジ、モデル3ロングレンジとか、テスラ狭いとか。だから必要で、でも LFP もあるから、継続的に踏切が必要じゃない LFP も、どんどん使っていくんだけれども、踏切を掘らなきゃいけない。どうしても。はい。ということで、フランツさんですね。ここからは。ここまで、ソーラーの話でした。なんすかこれ。来た？フランツがなんかビーグルデザインとか言ってるけど。何
？Doing vehicles with Franz for almost 13 years now.
So I joined Tesla in 2008 to vertically integrate design into the company. It didn't exist before. It was a pretty small team. It was tasked with designing the most beautiful, innovative, and well-engineered vehicles on the planet. No small task in 2008. There was not a lot going on in the EV sector then. Since then, we focused on constant improvement in cost, efficiency, innovation, things that you'll continue to hear about today, while continuing to design the most desirable cars. Today, we produce cars differently than we did 10 years ago, but the end result is always an exciting, futuristic, and desirable set of vehicles.
Back then, we only had a handful of designers and engineers like myself, but we had a great vision to radically change transportation.
So back in 2008, where we were designing Model S, we didn't have a factory. In fact, we had a really small engineering team and a tiny design team. But that allowed design to lead all the conversations. It let us innovate forward-thinking ideas like, how do you fit 7 people into a sedan? Or how do you make door handles disappear into the doors? Or putting a huge touchscreen into the center of the vehicle, something that had never been done before.
And then we won Motor Trend Car of the Year.
Yes, and we won Motor Trend Car of the Year in 2013. Our first, great award, first car. Pretty good start. Kind of a home run, I think. But that whole process resulted in a linear process that you see on the screen. We designed first, then we engineered, and then we figured out how to manufacture it.
Yeah, I think that's really important. When we were designing the car together, we didn't even know where we were going to build it, and so we came up with.
I didn't even know Lars when we were.
That's true. We didn't. So once we got Fremont, we were very fortunate, and we figured out.
なんかテスラ創業してからの話をずっと話しますね。2008年にモデル S を作ってどうのこうのみたいな。前振りですかね。そして2023年我々が作るのはみたいな。前振り？みんな知ってる話ですからね、ここら辺は。
but be much more affordable. And so we approached the process a little bit differently than the first time around. Now we had teams that we all worked together, so we were able to combine design, engineering, and manufacturing process all at the same time. But somewhere along the way, we changed the manufacturing process to be fully automated. And so we leaned into this whole new way of manufacturing a car, but we had already engineered it. So things didn't quite go as well as planned.
It was an amazing product, but it landed us in production hell. Many of us who lived through that carry those battle scars. It was a great idea, but it wasn't the right timing. Like Franz said, automating something that we designed to be built manually is super hard. And we have many, many failed examples of that at the Fremont factory that we ripped out. But some of them eventually still work. This is one I actually worked on with a small team of engineers. It's still running today. And some of the engineers that came by said we couldn't do it. Are no longer with the company, but it's running and it's running faster than ever.
あと何時間やるんだろうか。ね、ちょっとね、もう
we kind of self-imposed constraints on the design. When we were doing it to be built manually, we really didn't think about it. But despite all that, Model 3 is the best-selling EV ever.
まあ、大体1時間ぐらいやっちゃうかもしれないですけどね、まだあと30分以上かかるような気がするけど。まあ、この辺もですね、今までの歴史を語ってますよね、プロダクションモデル3の。で、サイバートラックですよね。
Forming full hard stainless steel isn't rocket science, but it sure isn't easy, and it limited the way we could do it.
Yeah, absolutely. it really forced us to think about designing something in a way that you couldn't normally stamp panels, you couldn't form them in a traditional way. So you ended up with very linear bending processes that are just not in automotive kind of language of manufacturing today. But it actually created a very efficient and process and one of the most dynamic designs ever, I believe. It's definitely something that's going to change the road landscape.
Hopefully you guys saw it down there and you experienced it. It's definitely real. Those are real trucks. We're on our way to build them. But what that stainless steel opportunity did for us, it has let us rethink the factory footprint. We don't stamp those. That's a huge part of it. We don't even paint them. So our footprint got smaller, and we started to think about innovative ways to take those
あ、あき
constraints
さんね、おはようございま
and make
す。
great products.
But that constraint didn't really change the end result of the truck. It's a super dynamic truck, and it has all the
ちょう
functionality
ど
you would
面白くなって
expect
きそうなところ
out
で
of
す。
any of the other competitive trucks. And the best thing about it, it's coming this year.
So ideally, after all that, we would design, engineer, manufacture, and plan for automation happening together. It gives us the opportunity to question requirements. This is something that is fundamentally only available at Tesla. In the places I used to work and the top manufacturing companies in the world, they don't sit together.
Yeah,
We are one team.
Nowhere I know has all these teams together thinking about these processes from the very beginning.
In fact, all of those engineering teams, manufacturing, design, automation, they're all in one org. They all report to one person. We can't point fingers
こ
at
こ
each
まで
other, so we
は
have to solve
あ
them
の
together,
テスラの
which is the best
サ
way
ス
to
テナブ
do
ル
it.
エナジ
The traditional
の
way of
未来を
making
ど
a
う達成
vehicle
してい
is
くかみ
this.
たいな
You stamp it,
採
you
用
do build a body
ソーラー
in
パネ
white,
ル
you
とか
paint it, and you do final
なん
assembly.
か
And what's interesting is
そういう
these
感じの話でした
shops
ね。
are dictated by the
まだ面白い
the
話はその出て
organizational
ないです。
structures that exist.
これからで
And they're
す。
dictated by the boundaries that exist in the factories that are laid out. If something goes wrong in final
いやー、ア
assembly,
ップルの
you walk the whole line.
WWDC みたいな盛り上がりはちょっとわかんないです
You
ね。まだね、その
This
サ
is
プライ
at
ズ
the
というか、
tail
うおーみ
end
たいな
of
のは来
its
てないんですよね。
manufacturing optimization. Henry Ford first invented this assembly line in 1922. It's been 100 years, and it's really hard to make a change after 100 years. And when you watch it happen, it's actually really silly to a guy like me. You take all these stamp panels, you put them together, then you put them in a framing station, you build a body that looks something like a car, you put the doors on, and then you paint them. Once you get the color, you take the doors off, and then you start putting the interior inside the car. It comes in through the openings that already exist. I wish it went in like this big piece like this, but there's actually people coming in and out of the car. There's awkward, movements. Then we lift the car up, we put stuff from underneath it, we put it down, then we put the
面白いね、
seats
こ
in
の
the
アニメー
car,
ション。
and finally we close it all out with glass and we bring those doors that went away for a trip
え
and we put them back
ー
in
今
the
までは
car.
そうやって作ると。
Most of the time, we're doing this with a big giant car and moving it and doing really nothing to it at all.
What's funny though in this kind of whole process is that just recently Toyota
何時までやるん
just
から
called
なんか
this
サ
an
プライズない気が
engineering
してきた。
work of art.
ああ、僕もです。
True.
サプライズ頼むで、マジで。
The Model Y.
That was humbling, but at Tesla, it's not good enough. If we're going to scale the way we want to do, we have to rethink manufacturing again. As part of the master plan, we have to make another step change in cost. We started this on Model Y.
まあこの辺も今までの話ですよね。今までの車作りって結局大量のパーツを使ってアセンブリしてたけれども、ギガプレスで一発で作るようにしましょうねっていう話だから別にそんな新しい話じゃない
We
です
put the
よ
seats
ね。
in the interior on the battery, and we bring it up through a big open
株
hole
価
and
も
we assemble it.
株価は
And
別
this
にプラ
allowed
マイ
us
ゼ
to
ロって
do
感じです
things in
ね。
parallel, fully rethinking the process and reducing the final assembly line by about 10%. And we thought maybe we could do this other places.
Yeah, I mean,
まだ
in a way,
投資家の人はニュートラル
the,
な
the
感じですね。
constraints become part of the solution rather than a problem.
So when you think about what I'm trying to say, I really want to hammer this home. When you have a car that's about 5 meters long and you have people working around it like we did in Model 3,
お
and we change that to this process where we take different parts of the car and we can do more at the same time, like we did with the Model Y structural battery pack. What you see here is us doing that on the front part of the vehicle or the rear part of the vehicle. That means we can get more people working on the car, or robots, working on it at the same time. That means we have better operator density, less time doing nothing. I call that space-time efficiency. it has nothing to do with quantum mechanics. We can have that conversation later. But we get 44% more operator density, which means more work, less time walking back to the station, 30% improvement in space-time efficiency. And because we're not building it in and out of the car with those slow movements of those robots I showed you from production hell, when we go to automate it, it's going to be a lot easier. In the end, that will probably look something like this, where we balance parallel and series manufacturing in a way where we only do things that are necessary, with a much shorter final line, blocking a lot less of the entire rest
これ
of
メ
the
インなのかな、なんか
factory,
ほ
so we
ら
can optimize
なんだっ
material
け
flow using the best
テ
practices.
ィザー画像も完
What
全に
that
こ
means
の
it's going to look something
ボ
like
ディ
this,
の画像だっ
where
た
we
じゃないで
build
す
all
か。
the sides of the cars
組み立ての
independently.
効
We
率
only
よくなり
paint
ま
what
し
we
た
need
的
to,
な。
and then we assemble the parts of the car once and only once. We put them where they need to go. The interior is attached from a bottom up or a top down strategy, so there's more access for those robots and people. We aren't moving heavy objects around and doing nothing to it, and it means we're doing more work on the car more of the time. Then, when we take it, all of these tested sub-assemblies and we put them together, we finally assemble the car only one time, putting the sides on with all of their parts to a front and rear that was already assembled,
すげえな。
carrying the floor
そ
and
の入
the
れ方。
seats, and finally boxing it out
そ
with the doors
う。なるほ
one
どね。
time, just like
面白い
Cybertruck.
ですね。
So in the end,
今ま
we
で
get
と
the
全
same
く
car,
違う組み立て方法
but it's
だ
not
ね
going to be a Model
で
Y.
今まではさっきみたいな映像で
This is a Model
骨
Y
格
for
作ってからそこに
illustration,
パーツを
not
どん
the
どん
next
付け足していくって
step.
話だけどテスラはこれ
In
から
the
作
end,
る
what
の
does that
は
mean? To
なんかもう
increase the scale and
パー
adoption
ツ
of
ごとに
electric
先に
vehicles
全
on
部
the
パー
order
ツ
of
つけちゃっ
magnitude
て
I've just showed you.
最後に
We have to make
そ
constraints
の8
parts.
個ぐらいになったパーツをガチャンって
It
一気
leads
に
us to greater
シ
than
ートも
40% reduction
下から
in
入れますみたい
footprint,
な
which means we can build factories
へ
faster
え
with less
まあこう生
capex
産
and more
工程と
output
かを
per
作ってる
per
人
unit.
からしたらうわなんだこれすげえってなるんだろうけど
Faster,
別になん
less
か僕た
capex,
ちが
more output
この
per
ユー
unit
ザー目
developed.
線で考えると
Zach's going to
あ
go
あ
into
効
more
率よくなっ
details
た
on
ん
this
だす
later,
ごいっす
but it
ね
also
みたいな
means through this
感
innovation
じ
and
で
some
しか
of
ないという
what
か
my other
う
engineering
ん
colleagues
別
are
に
going
ア
to
ウトプ
talk
ッ
to
ト
you
が
about
そ
in
れ
the
で変わ
future
るわけじゃないからね製
will
品
reduce
のね
costs as much as 50%. This is the 2 for 1 concept you hear me and Elon talking about on earnings
う
calls.
ん
Yeah, so I think our track record proves that we can deliver the best cars, and we deliver the best cars in spite of,
なるほどね。
because of
もしかして
these
それだけ
constraints. I'd
も
love
しかしてそれだけとか
to
言って
really show you what I mean
え
and unveil
これだけじゃないよ
the
ね
car.
まさか
But you're gonna have to trust me on that until a later date.
勘弁してくれ
And I promise we'll always be delivering exciting, compelling, and desirable vehicles, like as we always have.
Have we ever not? Yeah, we
これ最後までわかんない希望を捨てずにちょっと頑張りましょう
speed.
もうなんかない気がしてき
So
たな
with that, I want to bring on Colin, who's in charge of making our cars go fast.
大丈夫かなあいなくなっちゃったよ最後
Thank you, Lars.
こっからテスラのやることらしい
My name is
あ
Colin
これ結構
Campbell,
長
and
そう
I
だ
have
な
the real
こ
privilege
れ全部やるの
of powertrain engineering
1234567
here at Tesla.
8って
We make
嘘
the fastest cars that you can buy for the money, whether they're electric or gas. And the Model S Plaid that we're looking at here has more than 1,000 horsepower.
ポルシェより速く
Pound
プリウス
per
より効
pound,
率
the
的って言っ
motors
て
in
ますよ
that car are as powerful as jet engines. Our
具体
cars
的
are
な
super
車種名
fun.
出すの面白いです
People
ね
absolutely love driving them. And the other thing that you probably all know about our powertrains is that they're efficient. Our cars go 25 to 30% further than other EVs in our class for the same amount of efficiency. But at Tesla, efficiency means
まあ
more
確か
than
にモデ
just
ル Y の
reducing how much
効率はいい
energy
です
the
ね
cars
燃費すごくいい
use. It's about how we develop, how we manufacture, how we refine, and how we scale the powertrain. Now, the Model 3 and Y powertrain is a great example of this broader meaning of efficiency.
いや
So
この
essentially
さっき
launched
の
it back in
組み立て工
2017,
程はも
we continuously
新
improved
型
that
モデル3
powertrain
からやるんじゃないですか
and the
新型っていうか
factory
そ
that
の
builds it.
モデル
So
チ
the
ェン
drive
ジ
unit, the engine of the
ま
car,
あアッ
is
プデート版のモデル
20%
3から
lighter for the same power. We used
やりそうな感じがしますけどね
less heavy rare earths than when we started. And the powertrain factory, which is behind me today, is 75% smaller and 65% cheaper than the one that we originally built. And what I really want to emphasize is that we did all of this without compromise. Our cars are just as powerful, they go just as far, they cost the same or less, and the factories have the same output. So, how did we do that? We did it by designing the entire vehicle and the entire factory together as one company. And this sets Tesla apart. We have small and highly capable teams To make a critical decision, we can have the battery cell chemists, the mechanical engineers, the manufacturing engineers, the supply chain team, the automation designers, the software programmers, all in one room, working together in real time. And that allows us to make decisions
確かに
that
投
are
資
best
家
for
向
the
けの
whole
発表
car,
説明
to
だ
make
から
them
数
really
字並べる
fast.
感じの発表会
That
か
approach is unlike
まあ一応
traditional
そう
automotive
な
engineering,
んですけ
which is
ど
really fractured.
なんか
And
まあ
if
知
you
っ
were
て
to
る
go buy like a
こと
premium
なん
German
だね、大
electric
体。
car,
まあ振り
the
返るっていうの
engineers
もいい
who
んですけど
designed
ね
the。drive inverter in that car, they did not work for that car
な
company.
んだ
They worked for a
あんまりテ
contractor.
スラのことを知らない人向けのテスラが何をしようとしているか改めて説明する回って
I
こ
want
と
to highlight a few examples of what we've been able to do
わざわ
in-house
ざ
thanks to that unique approach.
う
So,
ん
inside the charger of your Tesla are transistor packages, and that's at the top of your screen here. And every electron that moves you down the road flows through one of these packages. We designed our own custom package, which is what you're seeing here, and we can extract twice as much heat out of that package as what we could buy off the shelf. And so what does that mean? It means that the silicon carbide wafer that's inside those packages can be much
これは
smaller.
まあイ
And
ン
silicon
バーターですか
carbide
ね。
is an amazing semiconductor, but it's
インバー
also
ターっていうかインバーターの
expensive.
制御装
It's
置
really hard to scale. So using less of it is a big win for us. And then on top of that, orchestrating all of these
新車
transistors
発
and
表は
making
まだ
them
され
switch
て
in
ない
the
で
right
す。
ways
何の
is
発表もまだないで
computationally
すね。
extremely intensive. It used to require 4 microprocessors, which are shown here in the bottom left. We have developed our own custom microprocessor. It's purpose-built for high-power electronics. It's
最
half
後
the
に持ってきて
cost,
じらすパターンなの
and
か
it
な。
does in
最後
just
にイーロン
one
が出
the
てき
job
て
of all of those
それ
4.
じゃあみたいな。
And these are just
みんな
two
お待ちかねみ
examples
たい
of
な。
many that I could use to showcase our expertise in high power electronics. And that expertise has allowed us to take the cost of the chargers that were in our Model S when we launched it in 2012, both the cost and the mass, and cut both of those in half. And even more important, power electronics, they're central not just to our cars. They are also central to our superchargers and to our energy storage products. And Rebecca and Mike will be talking more about that. So in addition to the work that we've
い
done
や
in
ー今日は
software
新
and
型車
hardware,
発表ないってパターン
we've
か
also done a
もし
lot
れ
of
ない
work
気がして
in-house
き
on
ました
software. So this is the
あ
drive
ーそ
unit from
れ
Model 3
ね
Line. If we take a
確かに
cross
ちょっと
section,
どうなんだろう
see the stator and
結
the
構
rotor,
長いですからね
they're
なんか
responsible for
だってこの今
the
パワー
core
トレイン
function
で
of
し
the
ょ
drive unit,
このパー
which is
ト
converting electricity into
終
motion.
わったら次なんだろうなん
And
かさっ
our
き
custom
サークル
software
があっ
lets
て
us simulate
8
the
個ぐらいやったか
rotating
な
magnetic field that is
まだこれ
responsible
関連
for
の
that
1個
conversion.
ブレイクダウンし
Getting
た
that simulation
話が4つ
exactly
ぐらいあるって
right,
ことですよね
it's central to the cost, the weight, the size, and even the sound of the drive unit. Now, you can buy software that will do
こ
all
の
of
ジ
this.
バのシ
But
ミ
our
ュレ
tools are faster,
ジバの
they're more accurate,
制御
and that was not easy
も
to
全部
do.
インハウスでやってますって言っ
And
てま
that
すよ
allows
ね
us to quickly iterate through millions of possible drive unit designs to find the best one. I want to highlight one more area where Tesla really excels because we integrate work that is often farmed out. So when you are making a new product, it's not enough to think about the product itself. You have to think about how you're going to make it at scale. So at Tesla, our powertrain and our powertrain manufacturing equipment is both designed under one roof. The engineers who are designing the motor, they are in the same room as the engineers who are designing the machine that's going to put that motor together. And that collaboration pushes us from day one to design products that are not only high performance, but are really easy to assemble. So, all of this expertise that we have in the powertrain team, in hardware, in software, in manufacturing, it's going to have a major impact on our next platform. In our next powertrain,
Oh.
those silicon carbide transistors that I mentioned that are key component but expensive, we figured out a way to use 75% less
あれちょっと出て
without
きたよ
compromising the performance
Our
or the
next drive
efficiency of
unit
the car.
will be even more scale
And of course, we know that battery cell supply is one of the constraints on the scalability of EVs right now.
ほう
Our new powertrain is
このな
compatible
んか
with
ちっちゃいやつですね。さっ
any
き
battery
バンみたいのがあっ
chemistry. That will
て、
give us
その右
great
側にあった、
flexibility
これだから
in battery sourcing.
25,000ドル
If we
の
want to
テ
make
スラ
EVs
車で
more
すよ
accessible
ね
to。people, they have to be cheaper. We've reduced the drive unit cost to about $1,000.
なんか25,000ドルで売り出すためには
We don't think
相当
any
コストカ
other
ット
automaker
を
is even close to that
やんなきゃいけない。って意味で、モーターの部
Finally, the
分も
bigger a factory is,
やっちゃうよ
the
というこ
longer
と
it。takes to build. If we can build the same number of cars from a
Silicon
smaller
carbon.
factory, we are going to be able to scale EV production faster. our next powertrain factory is 50% smaller than the one that's behind me today, even though it has the same capacity.
確かに。サプライズ前の演出じゃないかなと思わせた方がサプライズ大きくなる。確かに。さっきからなんとなくチラチラ見えてるんですよね。その次世代のためとか、さっきのカバーがついてた車がちらっと2台映ってたりとか、何なんだろうみたいなね。思わせる。今もさ、ネクストジェネレーションのモーターですみたいな。
It has environmental and health risks. So we want to do even better than this. We have designed our next drive unit, which uses a permanent magnet motor, to not use any rare earth materials at all. So how does all this fit into the master plan?
ネクストジェネレーションの永久磁石モーターはレアアースなくていいんだって。今モデル1に使われているモーター、レアアースは 500g、10g、10g って使われてるらしいんですけど、なんだろうね、コバルトとかかな。そうなんだ。なんかスケーラビリティあるよねって話これ。レアアースが掘れなくてもモーター作れちゃうよって話ですよね。大量に。
To the cause of sustainable energy, and that is why we can do what no other company can do. Thank you.
これ確かに前振りな気がしてきたな。その$25,000のテスラをどうやって作るかっていう風な話の前振り。どれだけ安くできるか、どれだけ大量に作れるかっていうの勝負になってくるか、そこをどう実現するかっていうのを先にこう説明してる気がしなくもないですね。
Pictured here is the low voltage system of a Model S from 2012. This car was primarily designed with vendor source controllers integrated by Tesla. There are over 300 low voltage devices that encompass everything from the mundane, like the light in the glove box, to the complicated, like the infotainment computer, to the safety critical, like the airbags, steer by wire, and brake by wire. The low voltage harness is built from individual wires cut to length, crimped and inserted into connectors, a manual process that is
これなんか左とか右のが今まで従来使われていたハーネス。
We want to reduce the size and complexity of the harness and enable automated manufacturing.
These wire harnesses introduce extraordinary complications, especially in the early stages of development and bring up of a vehicle, because when we're trying to bring up this entire system and we see that it's not working properly, we don't know whether it's a problem with the software, with the controller, the processor, any of the endpoints in this entanglement of wires. And so we have to go and debug everything all at once. And Pete's going to tell us about how we're going to make it better.
So I'm going to talk briefly about a few things that we've changed over the years since the Model S. With the Model 3, Tesla started designing an increasing share of our controllers by merging controllers together. And we were able to simplify the design with a significant reduction in wire count and weight.
12ボルト系統が特に変わったって書いてある。まあそれ前から言われてるんですけど、なんか S とか結構最初の方はハーネスが多かったけど、3めちゃくちゃ最適化されてすごい減ってるよみたいな。で、Y ではもっと減りましたみたいな。株価下がってきた？ちょっと見てみるか。嘘。
The original Model 3 controllers were
めっちゃ下がってんじゃん。
and built into Model
ウケ
Y.
る。
Those improved controllers were
さっ
then
きまで
moved
ね
back
200
into
ドル
Model
ちょいや
3
ったの
when
が
we
もう
introduced the
200 ドル
heat
切っちゃ
pump.
ってますね。
At that point, we had
みんなちょっと
shared controllers
慣れて
across
きてる
both
から
cars, which helped simplify our
微妙
supply chain.
だ
Those
と
Model 3 and Y
思い
controller
始めてる
designs
説あ
were
りま
then
すね。
updated and enhanced for the new versions of Model S and X that we introduced in 2021. For Cybertruck, we are now designing 85% of the controllers in the car. For the next gen platform, we're going to finish the job and be designing 100% of the controllers to give us full control of the design and the supply chain at the component level. Having full control of the supply chain at the component level has been critical to Tesla over the last few years as the supply constraints have hampered our ability to build cars.
And with that control comes control over all the software, which enables us to develop features and functionality that we never even dreamed of at the time we designed the hardware. So that's why you see software in your cars getting better and better over time in ways that we didn't even think of when we designed the hardware in the first place.
Yeah, Sentry Mode is one of my favorite last-minute changes. With the introduction of Model 3 in 2017, we deleted relays and fuses from the car in favor of E-fuses. E-fuses replace moving parts with solid-state transistors. They provide fine-grained control of the power system to software and allow software to do advanced things like load shedding in the car under adverse conditions. E-fuses also allow for software-controlled retries for transient faults, and they allow for detailed monitoring of the power system over time.
Yeah, the theme you hear a lot about today is software-controlled hardware. And when I think about that in my team, software-controlled hardware is fundamentally about being able to sidestep what otherwise would have been static trade-offs between one attribute or another in a piece of hardware. We are able, with software, to instill intelligence, context awareness, and context-specific behavior into what otherwise would have been a piece of hardware that had to
なんかサプライズありました。結局モデル2出さないと上がらない理論はどこに行きましたかね。裏にいるんじゃないですか。まだ何もね、新しい発表はしてないですよね。
We expect lithium-ion batteries to last for the life of the car, so we don't expect anyone to wake up to a dead battery ever again. This eliminates a major source of failures for our car, and the toolless connector makes it easier to service the car, and it also includes a software feature to allow validation that the connector has been properly installed at the end of a service event, which removes another source of failures in our cars. Obviously, the mass and volume savings are also significant, which is super helpful.
今まで通りの話ですよね。みんな知ってるような話。なんかそのパターン多いですね。まずなんかみんなが知ってるような当たり前の話をしてから、ちょっと新製品のヒントを出して終わるみたいな、それぞれのセクションが。まあでもちょっとダラダラしてる感じありますよね。もっとサクサクいってほしいですけどね。やるんだとしても。と文句を言う。まあまあゆっくり見守りましょうか。はい、ここからヒントタイム。製品のし何が出てくるのか。
One of the changes that we're looking to make right now is to change something that's been steady for the last 60 years, 12 volts. 12 volts has been, as I said, for 60 years. The demand for power in the car has been steadily increasing to the point where we now have to have pretty large wires to drive over 200 amps of current around the car, which increases the mass and cost.
48ボルト
On all future Tesla platforms, we will be moving to 48 volts. This reduces the current needed by a factor of 4. And since power loss in the harness is resistance times the square of the current, a 4x reduction in current leads to a 16x reduction in lost power while distributing energy in the car. That allows for smaller wires, smaller E-fuses, and smaller controllers. It also allows us to make those heat sinks smaller, or in many cases remove it completely, all benefiting the car in terms of mass and weight. 48 volts is the future for design at Tesla.
はい。ちょっと48ボルトになるらしいよ。低電圧系統が。嘘、やばいじゃん。サイバートラックオプティマス、ネクスト、テスラから。今まで12ボルトが業界標準でしたよね。テスラ12ボルトから48に変えるって言ってるよ。嘘。じゃあ12ボルト系のアクセサリーとか使えなくなるよね。でもその48ボルトにすることで E フューズとかいろんな半導体とかそういうのが小型化できる、減らせるって言ってますね。
To be effective, the network must be reliable, have low latency, and low jitter, and these are all attributes that we've been able to achieve with the current design. The design has eliminated most of the cross-car wires in Cybertruck, and with the next-gen platform, we're going to finish the job and eliminate all of them.
This consolidated vehicle network allows us also to make a whole lot more dynamic changes on the fly to how components in the vehicle talk to each other,
マジで
rather than the traditional approach of
ちょっと
separate
ね、皆さん
campuses
悲しいお知らせがあるんですけど、
And
バッテリーが少ないっていうね
one。of the nice things is that you can see the entire vehicle through a single connection, which wasn't possible in the past for debug.
このね、Mac のバッテリーがね、減りがすごくて、途中で止まりそう。やばい。
Across all of the organizations, not just for a given subsystem. Simplifying the wire harness will enable automation, 48 volts will allow us to reduce the size, mass, and cost of the low voltage system, and is one of the key things to enabling us to scale production of the low voltage systems for the Master Plan 3. David?
マジか。
So I joined Tesla in 2012, and even in those very early days of the Model S, we already had the ability to update software over the air in all of the controllers throughout the entire vehicle, at a time when other cars were just starting to update software in only their infotainment units. Furthermore, we've had sophisticated, anonymized data logging and telemetry capabilities that allow us to understand how the fleet is doing, what customers are doing with it, and how it's responding in the field to that usage. These two capabilities combined, OTA updates and data insights, give us the ability to iterate quickly on our software and to maximize the amount that we learn and proceed and the progress that we make in every one of those iterations. We've used these capabilities to inform countless design decisions in both software and hardware.
仕事に戻ります。はい、頑張ってください。
monitor and
また後
track
で
the use of
アー
the
カイブ
sunroof in
ご
our
覧いただ
cars
けれ
and
ばと思
found
い
that
ま
our
す。
customers never use their sunroof, so we made this easy decision to remove it.
Very barely, yeah. I haven't had sunroofs for a while. As another example, we are able to use our collision data to design our crash safety systems for
ここ
what
からは
happens in
FSD
the
関連
real
の話
world,
ですね。
far
これも見
beyond
たこ
what
とあるですよ
regulatory
ね。
and consumer ratings
この
tests
見たことある
prescribe.
ところから新しい
And
の
then
発表するパターン
furthermore,
が全
we're
部続く
able
の
to
か
use that
面白い
data to
な。
recreate in simulation all of those crashes
モデル
every
2
single
の話と
time
かって
we
多
make a
分
change to the vehicle's design
そのもっと後なんじ
to
ゃない
the
か
software
な。
that controls the airbags and other restraint systems. Here, on this graph, the gray dots that show up first are specific crash tests that are prescribed by regulatory and consumer ratings agencies throughout the whole world. And the rest of the color that fills in around and on top of it, those
やべ
represent
え
the crashes that
バ
we've
ッテ
seen
リーが持たな
happen
いか
in
も
the
しれ
real
ん
world.
あとね
Those
Mac の充
are
電が
what
ね
we design
18% しか
for
なくて
and what we test to.
今ねケーブルで充電しながらやってるんです
Last
けど
year, this data was used to
ちょっとね
change the algorithm for
あれ
seatbelt
なんですよ
tensioning to reduce injuries in the field,
この
which was
ライブ
OTA
配
to all
信
of
を
our
する
cars.
なんていうの機械
Here are
ソ
a
フトが
few
ですね
statistics
消
that
費電力
demonstrate
激
how
しすぎて追
staggeringly
いつかないです
quickly
ね
we gain new insights from the anonymized
ダブル出しする
data
か
that we've received from the fleet every day. Every day, 123 million miles driven, 1.9 million charge sessions, and those rates are only increasing as we deliver more and more cars into the world. As another example, we've analyzed patterns in the way the fleet drives and charges to optimally size battery packs for our next generations of vehicles. And you'll hear lots of other examples throughout the rest of the day about how we're using data to inform decisions in the product and in manufacturing. So you've heard a lot from Pete, Colin, and others about how important vertical integration is for us in hardware.
ああお
But
仕事
it's
に行ってらっしゃい
especially
ませ
important for us in software. And this is extremely difficult from the way the rest of the traditional automotive supply chain is set up. In most situations, all the controllers in the car are delivered by different Tier 1 suppliers, whose software is written by Tier 2 suppliers, who farm some of that software out to different Tier 3 suppliers, and so on and so on. Making a change that spans multiple components takes months of coordination before any work can even start. And furthermore, integration of software in the server side with what's happening in our vehicles has always been a core part of our DNA and enables us to do things that nobody else can. Most engineers think about the vehicle as a complete, consolidated, fully contained system. But in the software team, we think about the system as including the vehicle as well as all of our back-end server-side applications and infrastructure and the resultant feedback loop from the entire fleet that informs all the decisions we make as an engineering team. For example, we recently released a feature in Model S and X
準
that
務の時間ああ
automatically,
お仕事行って
predictably
らっしゃいませ皆さんね
adjusts and raises
もう
the
ね7時半ですか
suspension
ら
for ride comfort
結構ね
before the car hits a section of
平
rough
日だし
road.
ねお仕事
We do
行ってらっ
that
しゃいま
by
す皆さ
leveraging
ん
the fleet to generate a map of road roughness everywhere our cars drive. Sounds pretty simple, but requires coordination of software across a number of different components inside and outside of the car. The restraint control module, whose inertial measurement unit senses the road roughness, the autopilot computer, whose GPS module and localizer figure out where the car is in the world, our navigation server, which aggregates the anonymized telemetry from the fleet and annotates our map with things like updated speed limits, lane topology, and now, road roughness. The onboard navigation engine, which looks ahead of the route that the car is traveling on and determines whether things are about to get rough.
イーロン出てくるまでサプライズない
And
でしょう。
finally, the air
ね、イーロン多分出てくるの
suspension
最後
control,
です
which
よ。
takes all of
きっ
those
と
factors into account and decides
最後までサプライズなしかな。
continuously whether it is appropriate
ちょ
to
こちょ
adjust
こ出
the
てるんですけど
suspension
ね。なんか
for
ヒン
ride
トが。
comfort. And before we released this feature to the world, we sent prototype versions of it to the entire
最後にイーロン出
fleet
てくるんじゃない
that
か
ran
な。
passively in the background, sending us anonymous data about every time it would have engaged, which taught us exactly how it was going to behave in the wild, in every environment, in every circumstance.
Yeah, being able to test new algorithms in the background without
まあ
impacting
この辺も
the
自動運
car
転
is
の
really
AI で散々
critical
話した話
ability for us, especially for
で
safety
すよね。
critical things like automatic emergency braking.
And we've used it to
ヒントタイ
iterate
ムはヒン
on
トタイム。
early versions of our stability control algorithms, which were introduced
は
to the
は、イー
entire
ロンね。
Model
確かにニヤ
3
ニヤしながら
2017
Twitter
with
今裏で
extremely-
ね、ステージ
extremely
裏で
high
っていうか
confidence,
見て
even
そう
on
ですよね、イ
a
ーロン
very
ね。
foundational and safety critical function. Okay, so far you've heard me talk a lot about how we leverage our software systems to iterate quickly on the customer
これ切り抜いて5分の動画にまとめそうな、まとめられそうなぐらい内容ないってね。今のところね、今のところ多分2分ぐらいで終わりますね。重要なところを切り抜いた
So
ら。
for example, in the early days of manufacturing Model S, we very quickly realized that there are a lot of different ways you could misassemble a car. You could forget to plug in a wire, you could not fully set a connector, you could pull a part from the wrong bin. So when we designed our manufacturing processes for Model 3 and all of our other vehicles going forward, we took a page from the software playbook which says, test early and test often. And we applied that mantra to every single car that we build at every step of the assembly line. So now, when a production associate plugs something into the car, the central car computer
これ
sees
面
that
白いですよ
connection,
ね。その組み立て工
confirms
程
that it's
に
the
もこの
correct
ソフ
part
トウェア
for the
が
type
活
of
用さ
car
れ
that's
ているみ
supposed
た
to
い
be
な。
built.
その組み立てどこまで組み立てられたかみたいなのもこう車単位の車のソフトウェアが管理してるっていう話。面白いですよね。これできるのはやっぱソフトに強い会社じゃないと。いや、今日私本業ありますよ。本業あるんですけど、私の修行時間はそんな早くないんで、まだ大丈夫です。リモートワークなんで大丈夫です。
Through a combination of onboard vehicle diagnostics, natural language processing applied to customer narratives when a customer schedules a service appointment, and a suite of internally developed tools, we are successfully diagnosing, scheduling, and ordering parts for over 33% of customer concerns in service.
Yep, and we also use testers built around our own controllers to test sub-assemblies before they get to the car, which will be even more important as we go to Lars's unboxed assembly strategy.
100%. We'll know with extremely high confidence that before those boxes get put together, that they are,
いや、これ長そうだな。
they themselves are assembled correctly. Okay, you've heard at lots of other events about all the awesome things that our autopilot and AI teams are doing to make the car drive itself, bringing us into the future of autonomy. But we've also been thinking for years about all of the other pieces that we are going to need to manage a network of autonomous vehicles. A lot of this has been happening behind the scenes in the form of platform-level functionality that we'll leverage later. But you've seen some of it surface already in terms of features that our customers and our internal operations teams can benefit from. Like in 2021, we built on top of our mobile app phone key and gave our customers the ability to share their car with anyone by sending them an invitation in a text message or an email. Last year, we introduced profile synchronization, which synchronizes your seat,
これ何時までですかってね。これまだね、何時までかわからないんですよ。始まって1時間ぐらい経ったけども。まあでもね、大丈夫です。きっといいことがある。最後には。まあ今話してるのは、ここまでは 最初ソーラーパネルの話とかがあって、相変わらずテスラのミッションであるサステナブルな移動を作ろうっていう風な話が最初のパートにあって、今2つ目のパートなんですけど、テスラがこれからどういう風なことをやっていくのかっていうのを、一個一個セクションに分けて、今ソフトウェアのセクションですね。で話していくってことですね。
So that customer data remains private and obscure, and the fleet only trusts commands from authorized parties. So that's a bit of a preview of all the pieces that we're building, looking ahead to our future of autonomous fleets. Synchronization, permissions management, security, and privacy. And that has been a whirlwind tour through some of the things that we're doing behind the scenes to enable the efficiency, cost reduction, and speed that we are going to need for our next phase of growth, for the next phase of the master plan.
では、
And so now,
そうだね、
to tell
生
us
産に
about
関
the
しても
latest
すごく
in
役
full
立っているって
self-driving,
話ね。
I'd like to introduce Ashok.
でもこれについては、だから大量生産するときのソフトウェアの活用方法みたいなんで、今ちょっとあったところがヒントが。ちょっとトイレ行ってきていいですか？ちょっとトイレ行ってきますね。一旦。でも皆さん見張っといてください。なんかあるかもしれないから。ちょっと行ってきますね。よいしょ。
Currently, when the car is not being used, it is sitting idly in parking lots, not doing anything. But when autonomy is truly unlocked, this car, instead of being idle, can go serve other customers. This fundamentally reduces the need to scale manufacturing to extreme levels because each car is being used way more. But this is no trivial problem. Building a scalable self-driving system is, I think, one of the hardest real-world AI problems out there right now. Nonetheless, we at Tesla have made significant strides in making one of the most general systems at solving this problem. There are three main parts to get right to build a scalable problem. First is the architecture of the AI system. Second is the data, and third is the compute. We'll start with the architecture. At Tesla, we are betting on AI, machine learning neural networks to help us build a general vision and planning system. In the early days, we used to have single camera, single frame neural networks that produced some outputs. These were stitched together in some post-processing steps for the planner. But this was very brittle and was not leading to great success. So what we did in the last few years is transition most of our stack into this multi-camera video neural networks. These neural networks take in the live feed from the car in real time of the 8 cameras in the car and produce a single unified 3D output space. There are many tasks that we produce, such as the presence of obstacles, their motion, lanes, roads, traffic lights, what have you. This is one example output that you're seeing here. This is from our occupancy network that predicts the positions of obstacles and their motion. You can see that it precisely captures the swervy, violent motion of this truck next to us. And this helps the planning system to avoid a collision with this object. Some of the tasks, such as lane connectivity, are more complicated to model using naive methods in computer vision. So we don't stop at the computer vision techniques, but we reach out to techniques in other areas, such as language modeling, reinforcement learning, to model this task. This is similar. These networks use similar techniques, such as transformers, attention modules, autoregressive modeling of tokens, similar to what large language models like ChatGPT do out there. With such an end-to-end system of solving perception, we have really removed the brittle post-processing steps and produced high-quality outputs for the planning system. Even the planning system is not stuck in the old ways. It is now starting to use more and more AI systems to solve this problem. The neural network-based planners are needed especially in complicated urban planning when there's a lot of other objects interacting with us. This is, for example, an intersection where we have to turn left while
よいしょ
leading
っ
to
と、
crossing
ただいま、
objects
ただい
and
ま
the
です。
pedestrians
ち
crossing the
ょっと
road.
休憩長いな。ご
We
めん
have
な
to
さい。
do
ちょっ
this
と、
both
あれですね。
safely
コンビニ
and
で
smoothly while
ちょっと
respecting
したものを
everyone's
買っ
right
て
of
ました。
way and preferences.
はい。
If this was done
どうでした？
natively,
なんかありました？
each configuration would take
なんか
10
新しいことありま
milliseconds
し
to
た？
compute, and there are
ない。
easily thousands of
テスラ当てられ
configurations
て、
to
マ
reason
ジショッ
about.
ク。あら、大丈夫ですか？
This would not be feasible using traditional compute.
私も
By
リモート
using
ワークです。あ、
AI,
本当？
we have packaged all of this
今、オー
into
ト
a
パイロット
50
FS3 で
millisecond
すよね。
compute
FS3 の
budget, so
話
it
して
can
たと
run
思うん
in
です
real
け
time.
ど、なんか新しい発表なさそうですね。この雰囲
The
気的
second
に。
big piece of this puzzle is the
こ
data.
れ散々 AI で
This
やっ
is
た
where Tesla has a
話
unique advantage because it can tap into the fleet,
なのかな？
tap into the fleet to access the exact data that can fix the
ああ、
problems.
そうですね。これ AI でやってましたね。同じような話を。
But raw data
同
is
じ
not
ところをどん
sufficient.
どん何回も同じように走
In
るこ
order
と
to
で
train these networks, you need labeled data. You need labels to supervise the networks.
どんどん
And if you only
デ
depended
ータが溜まってい
on
く
the
みたいな。
human labelers, this data would be too tiny to train these large multi-camera video modules. You need lots and lots of data to train these networks.
何もない。
Hence,
あら、
we have
何
built
もない
a
か。
sophisticated auto-labeling pipeline
なるほど、新しい
that
発表何
collects
もなか
data
った
from the
か。
fleet,
まだ。
runs computational algorithms in our data center,
まあ、気長に待ち
and
ましょ
then
う。
produces the
ね。
labels to train these networks. Here, you are seeing a 3D reconstruction that is happening by collecting various clips from different cars in the fleet and assembling them, all of them together, into a single unified representation of the world around the car.
あれ今話してる人ってこれあれじゃない？ AI でもさ、話してた。今の AI チームのリーダーの人じゃない？このインド出身なんかな。この
We don't have
独
to
特
stop
な
at
発音。
this kind of reconstruction. Once we have this base reconstruction, we
はい
can
はい、
build
これも AI
various
でついで
simulations
貼りま
on
した
top
ね。
of it
こ
to
のシミュレ
produce
ーター
an
で
infinite variety of data
そ
to
の
train
道
for
路の
all the corner cases.
状況を仮想的に再現していろんな天気だとかシチュエーションを
Synthesize adversarial weather,
やってるよ
lighting
みたいな。
conditions, and even the motion of other objects
あの
to test all the corner
Unreal Engine
cases that
使って
might
るって言
even
ってま
be
したね。
rare in the real world. Here's an example of why this data is critical and how we can solve problems using data. So back
音
in the
声二重
days,
になってね。あ、そうね。ちょっと
for
音
example,
声
in
キャ
this
プチャ
case,
ーと
we had some false braking where we thought this
コメン
car
ト
that's actually parked
そうで
there
すね。音
was
声キャ
going
プ
to
チャ
move
ーと
into
の
our path, and hence we were precautiously braking.
両方から出てるかもしれ
But
ない。
it is unnecessary because the
ちょっ
car
と
is
今これ
fully
変えると
parked.
また音出なくなりそうだから
So how can we
一旦
solve
このま
this?
まで
What we did was
すいません
we mined the fleet for similar cases where the car had false braking
株価見
due
てみ
to
るか
some parked car. We added
もう
14,000
after で
videos to our training set. And then once we
After
trained the
で
networks
今
again with this new data, it
197
now correctly understands that, okay, there is no driver in this car, hence it must be parked, so then there is no
なる
need
ほ
to
ど。
brake. And this is a systematic way to solve problems. On the chart on the right side, you can see that every time we add data, the performance improves. And then we can do this for every kind of task that we have in our system. And this is what we call as data engine.
うーん
We identify
こういう人たち
challenging
にとって
cases,
今
such
日
as
は
the
晴れ
one
舞
you
台
saw
ですね。
earlier.
ね、
There
確
could
か
be
に
other
ね。
different types of challenging
こうやっ
cases
て
too.
自分たちが開発したものを発表できるっていうのは素
Put
晴ら
it
しい
through
です
our
よ
auto
ね。
labeling system and produce the labels, add it to the
た
training
だ
set, and once you have the newly trained models, we deploy them to the fleet.
結構これはも
If we rinse and repeat this process, everything gets better and better.
うまあこれ結構技術的なことなんで何回
The
ね
final critical piece
話され
is
て
the
も
compute.
いいことだとは
In
思うんで
order
す
to
けど
train these large
前も言っ
models
て
in
た
a
話だ
reasonable
よ
amount
ね。
of time, you need lots of compute.
でこれは道場の前身となる今使っているスーパーコンピューターですね。学習用のコンピューター。
In addition, we also have high computers in the car which can run up to like 150 teraops of compute. On the back end, we have
いつもテスラってチャット欄閉鎖してるんですか？あ、そうですね。だいたいテスラのライブはいつもチャット欄はオフになってますね。世界で13万8016人が見てるんだって。結構見てますね。インベスターで注目されてますよね。
Once we bring Dojo, which is our training computer, on board into this. Just to give a reference, just the occupancy networks that you saw earlier
でもね、
use
ちょっと私思うのが、
1.4 billion frames to
今
train
日
these
サプライズがある
networks.
かどうかはちょっとわかんないですけれども、 一個考察として、そのライブの配信時間、今日朝6時からじゃないですか、日本時間。で、多分これって市場、その世界のどこの市場を大事にするかによって時間変わってくると思うんですよ。で、日本とか中国とかアジア圏ってこれ早朝なわけですよね。中国とかってもっと朝の5時とかそういう4時とか5時とかのレベルでの話じゃないですか。で、ドイツとかヨーロッパ、イギリスあたりは、まあ、夜なのかな。だから、ギリギリどの市場もみんな起きてるだろうみたいなね、メインどころは。みたいな時間に設定してるっていうのもあるんですけど、アジア圏が早朝なんで、そんなに大事にされてないっていう可能性ある。ってなると、小型車ってアジア圏とかドイツなわけじゃないですか。だから、どうなんだろう。なんかそんなに小型車の話が出ないんじゃないか説あったりなかったり。多分アジア市場を大事にしてたらアジア人がみんな起きてる時間に発表すると思うんですよね。あ、なんかいい論出てきたよ。あれ？何？起きてます？なんか新しい映像だな。ああ、米市場クローズからのスタートね。確かに。ちょうどね、株式市場がクローズしてからスタートしたってだけか。単純に。ちょっと待って、このオプティマスの映像初めて、新しいよ。ロボットがロボット修理してるよ。修理してる風な映像ですけど、実際には修理してないだろうが。面白い。おお、細かい運動できるよってね。ネジ止められるよって。アロハって言ってるね。面白いじゃん。マジやべえ。床に落とすんかい。
Real world AI. We're the most advanced in real world AI. So
何やねんこれ。
AI that drives the car.
ウケる。
Which you can think of.
ロボットがロボットを作る時代来ますよね。アイロボット的な。
So as we solve real world AI, I don't think there's anyone even close to Tesla on solving real world AI. That same computer and software goes into Optimus. So it's not that helpful to have a humanoid robot if you have to program every individual action. It needs to be able to walk around autonomously and solve tasks. You should be able to instruct it in simple things by showing visually what the robot needs to do, or just telling it what to do. So I think that's a key advantage that we have. And then we also are good at designing things for manufacturing and then manufacturing itself. So the actuators in Optimus are all custom designed Tesla actuators. So we designed the electric motor, the gearbox, the power electronics, obviously the battery pack, and everything else that goes into Optimus. We were quite surprised to find how little was available off the shelf. Because there's a vast number of electric motors, gearboxes and whatnot that are available in the world, and we found none of them were useful in a humanoid robot, literally none. So you have to custom design the actuators for a humanoid robot. And so the same team that designed the groundbreaking electric motors that are in the Model S Plaid designed the actuators in the robot. So, I mean, for practical purposes, what this means is that we should be able to bring an actual product to market at scale that is useful.
おじさん出ただけで2ドルぐらい上がった？テスラ株が？
And assuming that the things I'm saying are true, or at least I think they are true. It's just a question of the timing. you start getting into interesting questions of like, what's the ratio of humans to humanoid robots?
なんか
I think it might be greater than 1-to-1. You know, because you could sort of see a use, a
まあ
home
ロボ
use
ッ
for
ト
robots.
人に役に立つロボットの話ですよ
Industrial
ね。
uses for robots, humanoid robots.
ちょっとアフターのチャートが
I think
な
we
いん
might
で
exceed a 1-to-1 ratio
見れないけど、上がった
of humanoid robots to
テスラ株。
humans. It's not even clear what an economy means at that point. You know, since an economy is output per person times persons, but if output is much higher and there's no limit on persons, then what's the actual limit on the economy? You know, we're still pretty far from Kardashev scales here, but we're getting there.
あ、ハッシーさんおはようございます。よく寝ましたか？あ、まだ何もね発表されてないんで、ちょうどいいところに来たかもしれませんよ。はい。
But will probably be worth significantly more than the car side of things long term. So charging.
I think Rebecca's next for talking about charging.
Charge.
あれ？何？チャージング？でも音出てなくない？
Hi there. My name is Rebecca Tanucci, and I lead our charging infrastructure teams here at Tesla. And at Tesla Charging, we have understood since day
なるほど。
one
なんかオプティマスのところだけイーロンが話に出てきたみたいなね。感じ。最後にまた出るでしょイーロン。頼むでちょっと。このままで終われねえだろう。頼むで。
We've considered every use case. We think a lot about what it means to charge at home, even if that home is an apartment or condo.
はいはい。
And we
チャージン
spend
グ
a
パー
lot
ト
of
です
time
ね。
thinking about what does it mean to charge away
最
from home,
近発
including
表があっ
if
て、まあ
that's
さっきも
for
言いましたけれ
daily
ども、
commuting or if you're going
マ
on
ジ
a
ック
road
ドッグ
trip.
がアメリカでは
And this
始まっ
holistic
たりね。
approach has led to some pretty incredible results. In 2022, we provided 9 terawatt hours of charging across our various charging methods.
いや、スーパーチャージャーマジ便利ですよ。アメリカマジでね、どこにでもある。本当に。
And when our customers are away from home, they can visit one of our 80,000 charging points. That includes 40,000 of our beloved superchargers. Now, getting here has meant that we've spent 10 years building charging
ここま
infrastructure
で。
basically
ああ、ここまでの話ね、またね。ここまでの話と、これからの話ね。みんなちょっと寝てていいです。まあ多分みんな知ってるような話ばっかりなんでね、この辺はね。
First, we have the industry's lowest deployment costs. Our costs are often 20%, if not 70% lower than alternatives. And that goes for both our supercharging hardware and deployments and our AC charging product lines. A lot of reasons that we're able to achieve this, you've heard a lot of them here today. We're vertically integrated, we manufacture and engineer all of our own charging equipment. We share components across our different product lines.
めちゃくちゃかかるよね、お金がってこと。ニューヨークとかさ、これ、何 160K？ 160K っていくら16万ドル ?16 万ドルだから日本円で2500万円ぐらいかな。2000万ちょい普通かかるよねみたいな1箇所。あ、違う違う違う、2億円ぐらいか。普通は1個作るのにだいたい2億円ぐらいかかるんだけど、テスラの場合はその 75% マイナスでいいと。まあ、つまり5000万円でできちゃいますってことね。だからニューヨークにスーパーチャージャーを作る工場があるんですけど、そこでもう土台ごとそこで作っちゃうらしいんですよね、今。アメリカは。だから、土台ごと運んできてトラックで、ポンって置けばもう完成みたいなことらしいですよ。すごいよね。日本はまだ、そのストールとかをそれぞれパーツ船で輸入して運んで、一個一個工事して作るから、結構高コストらしいんですけど、アメリカはもうめちゃくちゃ低コストでバンバン作れるってことらしい。
This is where Trip Planner comes in. Trip Planner is our in-vehicle routing or navigation system. Other electric vehicle manufacturers, well, some of them have vehicle side data. Other infrastructure providers have site data. But at Tesla, we have both. And what that allows us to do is to use Trip Planner to route vehicles
このプランナーもね、アメリカでは賢いってい
and
うふう
away
な
from
ことはね、
congested
実
sites
感
so
しま
we
した
can
ね。そ
balance
の
our utilization without risking
目
wait
的地
time.
設定すると充電が必要だ
And the
と
results
スーパーチャージャーを
speak for
勝手に
themselves.
経由地
Over
に
the
設
last
定してくれるんですよ。
few years, we've been able to drive
アメリカの
up
方っ
site
て。
utilization by 30%.
で、多分これ言ってるのは、
That means
この
lower
数年
per
間の
while also
蓄積
cutting
データに
our
よっ
wait
て
time in half.
混んでるところと
And we think
か、
this
そ
can
の
get even
充電
better.
混んで
Today
ると
we're
充電
feeding
時間
Trip
が下が
Planner
ったり
with
充電待ち
real-time
が
site
発生するんだけど、それも予測しなが
information
ら
about vehicles
プラン
currently
ニ
at
ング
sites.
どこの
Going
スーパーチャージに
forward,
よる
we'll
か
be
を
moving that to
決めてくれる
projecting
か
site
ら
occupancy based
効
on
率
the
よく
understanding of what vehicles are
トリップ
currently
できますよ
routing
ね
to
っ
those
ていう風
sites.
な。
And
これ日本で
ultimately,
まだ
our
来てない
vision
ん
for
ですよ
Trip
ね、この
Planner
トリッ
is
プ
that
プラ
it's
ン
the
ナー。
air
早くね、
traffic
来てほしいんです
controller
けど、
for electric vehicle charging across
そのトリッ
all
ププランナーを使える
infrastructure
ほど
on
ま
a
だスー
global
パーチャージャー
basis.
がないっていうね、実態はあるんですけど。
And the last thing we focused on to get here is quicker charge times.
日本はね、
Really
自
proud
分で
of
ス
what
ーパー
we've
チャー
been
ジャー
able to
設定しない
accomplish
と、
here. We've shaved off
充電が足りなかった
30%
として
of
も
our charge time,
スーパーチャージャー
average
目的
supercharging,
地、経由地に
site
設定してくれないん
time,
ですよ。
visit time over the last few years. This has taken improvements on the hardware side, with our software, on our vehicles, and on our infrastructure, and we're really excited to continue
アベレージスー
pushing
パー
this
チャージング
trend
タイムだっ
down.
て、これ面白いね。波打ってるのが面白いですね。
Looking forward, the job does not get any easier. As you heard earlier, we aspire to a fully electrified global fleet. That fleet, from an industry standpoint, needs 9 petawatt hours of charging on an annual basis. And while Tesla charging certainly doesn't have to supply all of that, it does require that for our part, we have a few new focuses in order to scale. First, if you want a fully electrified global fleet, all of those
出た。
vehicles have to have a
この
great
前出たばっ
reliable
かの
charging
マジックドック来た
experience.
よ。
So, as many of you know,
誰で
recently
も
we have started
どんな EV でも
opening up
アメリ
our
カでは
networks on a
CCS1
global basis.
で充電できる。
Over 50% of our superchargers in Europe are currently open to other electric vehicles. We've also opened up in Asia Pacific with our first sites in
すごい
Australia.
ですよね。
And just yesterday, we opened our first 10 supercharger sites here in North America and the US to other electric vehicles. We've also invested a lot to be able to make this a really easy experience for our new customers. All you have to do is sign into our Tesla app to unlock a post and start charging. We've also, on physical site changes, we've also added hardware to our sites. They're called Magic Docks. And basically that is installed in areas where we have different charging standards, and they allow for other electric vehicles to come to our site without having to bring their own adapters or
いや、こ
hardware.
れ日本に来たらだいぶ
We've
変わるよ
also
ね。
just started
チャデモ
installing
バー
our
ジョンで。
fourth generation supercharger posts. Those are being installed in Europe first. And while it's not a big mention, not a big thing to mention, they do have longer charging cables so that we can more easily reach the charge ports of different vehicles. The second thing we need to make sure we do when we talk about scaling all of this charging infrastructure is we need to make sure that it's powered from renewable sources. We're very proud that over the last 2 years, we've procured enough renewable energy to offset the amount of charging we've provided to customers. But as we look forward and we talk about this fully electrified fleet on a global basis, we really want to make sure that the demand for charging more closely follows when renewable sources are available. Now, this chart is on an aggregate basis for the US, and it varies based on what your renewable generation sources are locally. But basically, what this shows is we want to kind of move that charging curve, and for solar and wind in this example, it means more daytime charging. And we think the best way to go towards daytime charging is to install AC charging that is convenient and low cost everywhere vehicles are typically parked throughout the day. So that's really the plan. While supercharging and home charging definitely stay a big part of the puzzle, our teams are currently scaling to install AC charging everywhere vehicles charge during
ま
the
あそうで
day
す
so we can
ね。
power them from
設置場所と
renewable
か、
sources.
その充電時間を促す施策をす
So
るこ
summing
と
it up,
で、
while we've spent
再生可能エネルギーが
10
一番
years
発電され
installing
る
infrastructure that's low cost, it's
状
efficient,
態
and it provides a great
と
customer
マッチしてる
experience,
よと。
we're really just getting started when we talk about supporting Master Plan Part 3. We've got to scale capacity on an industry-wide basis to 9
Destination charger ですね。
petawatt hours on an annual basis. We've got to open up to non-Teslas and make the charging experience for everybody really great. And we've got to power all of this via renewable sources. And one more thing, yes, we've got to scale our infrastructure, and
あー、出
yes,
た、
we
こ
want
れ。
to power it via renewable sources, but we're Tesla. So we also want to make sure that we're continuing to focus on providing really
90
incredible
年代ダイナー
charging
風のスーパーチャー
experiences.
ジャーステーション。
With that,
ができるとか
I
な
wanna
んと
welcome
か
up our leaders of supply chain,
サンタ
Roshan
モ
and
ニカ
Karn,
に
to talk a little bit about that topic.
チャージングセクションはそんなにヒントも何もなかったですね。あと3つあんのか。7。これを耐え抜いたものだけにサプライズがあるということかな。頑張っていきましょう。
And we've also got responsibility for indirect purchasing, construction procurement, and warehousing and distribution.
Hi, my name is Roshan. I've been with Tesla for over 14 years. My team manages vehicle commodities, solar, logistics, planning, and capital
ね、
equipment.
サプライズないですね。チャオジにならないとってね。
So today we wanted to provide you a quick
もう
overview
2
of
時間
Tesla's
経過
supply
してる
chain
し、終わる
and
か
what
も。
really separates us from the typical automotive
ね、もう
supply
2時
chain.
まあ発表
As
始ま
you've
ってから
seen
1
in
時間半ぐらい
presentations
経ってま
prior
すけ
from
ど、
Pete and Drew and some
やばい
others,
ですよね。
Tesla designs a lot
あ
of
と
the
3つもある
subcomponents that。go
アメ
into
リカ
our
はボルタ
vehicles.
とか
So
あるし、
we're
羨まし
not
い。
buying things that are off the shelf from suppliers. So
突
supply
然画
chain
面
is
に
not
新が出て
purely
て、
a
そういえばこ
commercial
の画面に映っ
relationship
てる
as it
車が
is in
始ま
most
った
other
り、
companies.
確かに
We
全然あり
actually
ますよ
have an
ね。
arm within supply
多
chain
分あと
called
3
supply
つ耐え抜いた後に何が
industrialization
出てくるかってい
and
う
the burden of
話
taking a drawing, a
なんでしょう
design
か。
from concept and turning it into
そう
thousands of
願いたい。
products produced at the right cost and at the right yield falls with this group. Of course, they work very closely with design engineering.
イーロン君
But
元気ない。
really,
本
the
当
level of detail
元
that
気ない
our
ですか？
engineers get involved in terms of building the capability of the suppliers is pretty detailed. So, you know, once we get a new part, naturally with electric vehicles, a lot of the supply chain doesn't exist. Our engineers would basically take the drawing, turn it into a manufacturing concept, do the equipment selection, and physically go to the supplier and stay there for weeks or months, however long it takes, to basically
ちょ
do
っ
the
とね、1
line
時
bring
間半
up. Once the line
椅
is
子に
brought
座
up
りっぱな
and
し
we're
で
hitting
下向いてるん
the
で、
right rate, the right quality,
ちょっ
at
と
the right
首が痛くなって
yield,
きてました。
then
来ちゃ
we
いまし
work
た。
on things like automation and yield improvement and those types of activities. So there's a big group of mechanical, electrical, industrial, you name it, engineers within supply chain, and it's their
今のところ
responsibility to take care of this.
特にはって
Now,
感じで
this
す
is a
ね。
huge
なんかち
strategic
まちま
advantage
ヒントっぽいのは
because
出て
we
たけど、
manage every detail of our supply chain because
なん
we're
か新しい
so
発表は特になかっ
integrated
たって
with our
感じですね。
partners that we know about issues before they happen. It's
朝
almost
日
live.
眩しいですね。
We've got
今日もいい
dashboards,
天気
we've
で
got
すね。
connections, and across the 10,000 or so factories across the world that are making our components.
新型発表はないやろ。
We have a pretty good
前回も
view of the
10% 下がった
health
し
of
って
those
ね。
suppliers.
いや、
And
ど
this
うだろう、
has
わ
been
か
a
んない
key
よ。
asset in how
新
we've been able to
型、
kind of manage things
新型の発表はないかもしれないけど、新型に使うプラットフォームの発表はあってほしい。
You know, supply chain is a game of perfection. Perfection is a passing grade. It's like you know, if one part doesn't show up, that line goes down, and our CEO finds out about it in less than 20 minutes. Tesla is very different than Apple. They outsource manufacturing, we do it in-house. So supply chain is kind of right in the middle.
わかんないね。
And perfection is increasingly elusive and very expensive if you kind of look at all the issues we've had to encounter over the past year. And today we're just going to talk about how we got
製品に
through
関する話
the
ね。
past, and then what are we going to do
ちょ
going
っとね、まあ
forward,
確かに
and how are we
投
gonna
資家
get
向
there.
け発
So
表会だ
let
け
me
ど、
draw your
長い
attention
っ
to
す
this
ね、
slide.
結構。
On the left, you'll see
もうなんかみんなも飽きてきてだんだん
existing portfolio of products.
視聴者数も減ってきてるもん
Right? At the
ね。
SNX platform. In the
ちょ
middle,
っとア
you've
ジア
got
圏、
3NY.
日
I
本
think
人とかだ
everyone's
と、
more than familiar
や
with
っぱり今から仕事行かな
those.
きゃい
And
けないとかある
then
から、
the Tesla Energy platform, which is a very high rate of
ア
growth
メリ
for
カ人の
us.
人もも
And
う、もう
you
いいわ
see
って
Forget
ね
the solar and superchargers.
and solar and
帰っちゃって
supercharger.
る人
Thank
もい
you,
るんか
Roshan.
な。
And you'll see a reduction in and then we basically got the tier 1 and tier 2 parts. This might be boring, but a tier 1 supplier is any supplier that builds and supplies parts directly for consumption in our 5 factories. And our tier 2 supplier basically does the same thing for a tier 1 supplier. So they are the supplier to our supplier. And depending on the supply chain of any one of these products, this can actually go
なるほ
down
ど。
to the
ティア
tier
1
6 levels. For
モデル
example, if you're
STX
talking
は
about the battery
3400
cell,
個、
we really get involved
SX は
with the mines
2100
of
個で
like
す
where we're
ですよみたいな
procuring
ね。
the lithium, the cobalt, and all that sort of stuff because we're
だい
procuring
ぶ
such
少ない
high
方なん
volumes
じゃない
of
か
it.
な。
So
他の
you'll
車と
see
比
a
べたら。
reduction in the number of parts on the SNX platform to the 3NY platform. And this is because of the great work our
こ
design
の状
engineers
態
have
の
done
例
of
えばモデル
making the car
3、
simpler
モデ
and
ル Y が
easier to
2100個
manufacture.
なんだけど、
In
じゃあ
parallel,
新型車両は
we
みたいなね。
actually
1500個ですみたいな話になるんかな、この後。
To a lot of suppliers for the SNX platform. There's a lot of suppliers that we invited to partner with us. And we used
あ、通勤中に見てます。ありがとうございます。おはようございます。
as sort of a filter
さらっと自社株買いしますとか言ってね。 い
technical,
や、テスラって自社株買いしなそうじゃないですか、あんま。
capabilities to match us, right? Like who do we invite to the party?
自社株買いってあんまりするイメージないんですよね。
And we,
こう
you
いう
know,
企業
we've really dramatically reduced the number of suppliers that we were dealing with for the 3NY platform, and this is an approach we'll continue to do.
e モビリティパワーのサービスエリア締め出し、いつやめてくれるんやろか。ね、e モビリティパワーでもね、利権がすごい絡んでますから、ネクスコもその公共の充電器じゃないと置けないっていう風なことを言ったりしてるんですよね。つまりそのテスラ専用の充電器はその高速道路エリア内に置くのはフェアじゃないっていう考えだから、やっぱね、高速道路って税金が投入されてるから、あんまりどっかのメーカーに偏るってことが日本のあれ的にやんないんですよね。だからこそマジックドックなんですよ。他の車も充電できるテスラスーパーチャージャーってことになったら、高速エリア内にスーパーチャージャー設置できるんですよ。一応できるんですよっていうか、なんていうかな、ダメな理由はなくなるんですよ。だからこそマジックドック頼むでって感じなんですけど。600人使用してる。あ、本当に今何人使用してるかな、全然僕見てないんですけれども、今何人 ?600 人もいるんですか。ああ、めっちゃいるじゃん、本当だ。皆さんおはようございます。ご覧いただきありがとうございます。
On the other side of the heatsink, you've got the MCU, the multimedia cluster board. This board is equally complex. It's also double-sided.
あ、MCU の話もしてますね。MCU ってか。これハードウェアハードウェアの話も出てくる。
So this assembly requires taking those two boards and
これ
then
ハードウェア
bonding
3です
them
ね。
to a heatsink
多分。
that's hermetically sealed as an assembly, of course flashing the software and all that sort of stuff. And then that's one part number that comes to Tesla. So this is an example of one tier 1 part number that's a very complex assembly to manage at the tier 2 level. And there's more than 7,000 components here. There's you know, as we stand here,
これハードウェア3か。
components being assembled
3
onto
ハードウェア
a computer
2、
every
3か
1.4
な。
milliseconds. The line that builds this computer is the length of a football field. So it's quite complicated. And initially when we first started
長
building
い
this
ね、
board,
今
due
日
to
ね、
the
長い
complexity
で
of
す
it,
ね。
we
でも
had
今、
to rely
ちょうど
heavily
今、
on
これ、
labor. But
今からかも
once
しれ
we
ない。
dialed in the quality,
今からね、
the
来た
rates,
ちょうどいい
and
ところ
the
に来たかも
yield,
しれないで
we
すよ。
started focusing
今、
on
間も
making
なく
this
こ
more
の
efficient. The only way to
前
control
振り
cost
が
is by
もうちょっと
removing
したら
labor.
終わりそうって
The
感じ
first
の
step is removing labor. The second step
局
is
面で
fully
す。
automating. The third step is turning off the lights and letting the factory run, ideally. And that's going to be the goal for us here. So 95%, but our work is not done. We're going to be going a lot
197 ド
further
ル
than。this.
今株価ア
So
フターで。
this illustrates the point that
あ、EV ラフジャパンさん、そろそろ仕事開始なので、あと15分ぐらいが限界。残りはお昼で、ぜひぜひ、アーカイブチェックしてみてください。
is our involvement in all the details with our supply engineers that are Tesla employees. They're Tesla supply engineers. So they're like on our payroll that go and ramp up these capabilities at our suppliers. And then just managing each and every attribute of it. You know, 7,000 a day through the chip shortage.
産業でまとめ。ね、これ多分ショートにしたら一番わかりやすいんだろうけどね。インベスターデー2023ショート。30秒まとめみたいなね。あとで作ろうかな。
It's also about logistics and a lot of other things. So I'll hand it off to Roshan for sharing some stats.
Yeah,
川
so
西関
talking
する
about
話も欲
inbound
しかった。ああ、あり
complexity,
がとうございます。
just over the course of just last year, we moved about 16 million pallets
インバウ
from
ン
our
ド
suppliers
コ
to
ン
our
プレク
factories.
シティ。
Just to visualize that, if you put those pallets side by side, it could cover the half the circumference of the Earth. And talking about again the tier 2 complexity, over 1 billion electronic
Supply chain
components get moved every week
Supply chainの話。
to support the production that Karn and team manages.
This is right now 1 billion components a week.
Right.
52 billion a year. This is going to go up, by the way.
And on top of that, we also have the responsibility to make sure the right component is supplied to the right service location to support the growing fleet of our vehicles. And we have about 685 service centers that these components need to show up just in time. And then we've also been, as a result of pandemic and even before that,
まあ、いろんなパーツを45の国、685の拠点から持ってきて買ってるけど、まあ、そのソースを1個にしない、まあ、どのメーカーもそうだと思うんですけど、サプライチェーンのソースが何個も同じ部品でもあるよと。まあ、特にほら、半導体の話とかもそうでしたけど、テスラって7個も8個もボディコントローラー用の半導体を使ってるらしくて、まあ、今半導体不足でそのボディコントローラーが全然、あ、そうそう、これ、まさに今出てるこの半導体不足で車作れねえみたいなのが話題になったじゃないですか。その中テスラはいろんなところからボディコンピューター用の、まあ、ボード、チップセットを大量買いしてきて、ただそれぞれ制御のプログラム違うんで、そのテスラオリジナルで自分たちでその制御プログラム、ボディコントローラー用のチップに合ったプログラムをまあ作って、まあ、MCU の中に組み込んで信号をそれを送れるようにしてるっていう。だからいろんなソフトで解決したってことですね。それに対応できるいろんなボディコントローラー用のチップに対応できるようなプログラムを作りまくって、いろんなところから買い漁って作ってる。だから車も安定的に作れたよっていう話ありましたよね、1年前ぐらいだけど。
And also, in many instances, we had many, things that we had simplified.
ちなみになんですけど、あとね、Mac の充電が 8% しかないんですよね。で、今充電しながら一応やってるんですけど、1分に 1% ずつぐらい減ってるから、長くてね、あと1時間ちょいぐらいしか、まあ長くて1時間かな。残り1時間ぐらいしか配信できないかもしれん。途中で切れたらごめんなさい。いや、ちょっと切れたくないな。でもちょっとね、もう、一応テスラの USB から充電しながらやってるんですけど、ちょっと残念ながらもしかしたら途中で切れるかもしれん。その前に早くしてくれ。もう2時間ぐらい配信してるよ、これ。
Difficult but good experience. Exactly. We learned a lot. Yeah, and as we were just figuring out to work with COVID, then the port congestion hit on the West Coast. Logistics lead time went up by twice the amount, and we were operating with less than 35% accuracy in the system. That means at any given point, the ETAs of the vessels were 75%
すみませんね、なんか。
So, we figured out how to work
僕
with
が
that,
謝ることじゃないんだけ
and
ど。
then the chip
ごめんなさい。
shortages.
テスラの視聴者数もさ、今、画面左下に出てる12万6000人、さっき13万8000人ぐらいいたけどね、1万人ぐらい減りましたよ。
It's mostly behind us, and I think the results speak for themselves. Tesla was able to grow production volumes at a time where the rest of the industry had a hard time staying flat. I think they shrunk, actually, cumulatively. And we're often asked the question, how do we manage through it? And the answer is very much kind of baked through the presentation today. First, we design our own electronics. So in order to control costs, we've really had to go and build relationships with all the tier 2 suppliers to negotiate them directly. So these relationships were formed, over 10 years ago, and we've really got to know them well.
うちのテスラがすいませんね。すいませんね。うちのテスラ呼ばわりしちゃってごめんなさいね。そうそうそう。すいませせんね、うちのテスラがとか言って長くてダラダラ喋っちゃってみたいなね。いやいやいや、恐れ多い、すいませんでした。テスラさんすいません、僕が勝手になんか管理者みたいな、監督者みたいな言い振る舞いしちゃってすいません。はい、アップルの発表会みたいに要点だけ短い時間で話をし、まあね、名前がインベスターデーだからね、文句は言えないんですけどね。でもテスラの発表会って結構長いですよね、毎回ね。AI でしかり何でもそうだけど。締めにイーロンからサプライズあればいいけどね、なんかしれっと終わってもおかしくないからね。じゃあもう今日は解散みたいな。頼むよ、本当に。
So the question gets asked, is Tesla going to basically break the chip industry? The answer is no. But let me walk you through a logic on that. So as it stands right now, a Tesla enabled with a full self-driving computer has 4 times the silicon content of a regular vehicle. So at about the 2 million run rate, we're consuming about 700,000 12-inch wafer equivalents. That's the industry term that's thrown around for capacity in silicon. That's how much we're using, so a little bit below a million. And the global wafer capacity, based on the estimates we've seen, is about 135 million. So we're about half of 20 million. When we get to 20 million, and if we don't make any simplifications in terms of part count, which is also a separate work stream, I think Colin talked about it, we talked about it. We're not going to have all these different components. We're really going to simplify the architecture. Because simpler is better. But even if we don't do that, and we take the most pessimistic case, we're going to need 8 million wafers, okay? And the industry is going to scale to 200 million by that point. So still, we're less than 5% of the market share. And if we run the same offense we ran all along, and continue to work with our partners and you know, invest in fabs and invest in capacity, we'll have the capacity ready by the time we need it. So I really don't see this as an impediment from a supply chain perspective to get to 20 million.
省電力モードになったかもしれない。
Now, I would like to talk about a page that we took out of the electronic playbook and applied it to the mechanical side. Our vehicles use currently the heat pump based technology for the thermal system. But before heat pump, our vehicles used to have a dispersed thermal system connected by hoses. Engineering was inspired from circuit to circuit boards and then created a system which was extremely integrated, where 60% of the system was the size of a basketball size.
Next generation thermal architecture.
Where it contained about 100 components, 50 sealing interfaces, and several different manufacturing processes, all with packaged into this tight size. Now, why are we talking about this? Well, we launched the system right during the outbreak.
First million vehicle, and about 18 months.